And of course, there was always this thing which remained with us, whether digital or analog, or whether it's going to be virtual or reality. That kind of a thing is always going to be there, and people are going to argue about it. So let it go on. It's nothing wrong about it. But I see a lot of people from outside participate. I mean, participants, many other.
Yeah, yeah. Yes, sir.
Yeah,
We have a lot of new names.
yeah. I think one gentleman, Sarath Aital, is here. He's from PES, Bangalore.
Yes, sir.
He's
Yes, sir.
Yeah.
he's brother of Professor Dr. Bharat Aital. He was our professor at IIT Kharagpur, if
Oh,
I'm not
really? Okay,
mistaken.
okay. He's a speaker today. Huh?
And he's also an architect, Dr. Mr. Sharat Aital, if I'm not mistaken.
Yeah, yeah,
Yes,
yeah.
sir.
He's teaching at
Yeah,
PES,
yeah.
Bangalore.
Yes, sir.
So I keep on informing him. He is in my network, so he knows what we are doing. I keep on informing him about things.
Yes, sir.
Yeah. So nice to be here. And the idea is that we send the message to the architecture heads group also. So hope, I mean, the message is disseminated through them. But it was like very unique conference because so many people from abroad, so many people, very select people. It was quite, and many of them are actually young people. So it was quite good.
Hi, can you hear me?
Hello.
Yes, ma'am. I can hear you.
Good afternoon,
Hi,
ma'am.
good afternoon.
can hear you.
How are you?
Hi, Geeta. This is Jaffa from the architecture school at VIT. We're not able to hear you, but is our audio working? Just check that. Check it out.
Yes, sir. Hello, Geeta ma'am. Please speak something. Just checking once more. No,
Audio
your
is not coming
audio is
through.
not coming, ma'am. Please, yeah, just check your headsets and all.
We just heard, ma'am. So maybe some loose connection or something.
Yeah.
Hello?
Yes, ma'am. We can.
Okay, thank you.
Hi, Geeta. This is Jaffa Khan, director of the architecture school here at VIT.
Hello, hi, Mr. Jaffer. Pleasure to meet you.
Pleasure to meet you too, and we're happy to have you here and to give us the keynote address. I'm sure we'll have lots of things about what Atkins is doing in India.
Sure. It's my absolute pleasure, sir, to be part of this session. So thank you so much for giving me this opportunity.
So this firm is based in Bangalore, isn't it? Is it in Bangalore? Head office?
Yes. Yeah, that's right. We are headquartered in, the India office is based out of Bangalore. Obviously, as you know, we are a company which is now part of SNC Loveland. So the SNC Loveland is headquartered in Canada, and Atkins has presence across multiple regions. UK is the largest.
I did my master's at the UK, so we long time back. So we follow up with WS Atkins. I mean, they have not only Atkins but also Arup, who are very closely associated those days. I'm talking about
Correct.
5 years back, 35, 40 years back.
Correct.
So you
True,
are
true.
next to that that new building, Prestige building, isn't it? Behind where that's on St. Mark's Road corner, next to the petrol bunk. Is that the building where you guys are?
No. So we are located on Ali Asgar Road, which is off Millers Road. So Safina Towers. So that's where we have our office. Yeah. Okay. I just want to check if I'm able to sort of share my screen. So maybe before
Sure, ma'am. You
the
can.
sessions done. Is it coming through?
Yes, ma'am. Visible.
Yeah, we can see.
Yes.
Okay, thank you.
Ma'am, your voice is breaking a bit though.
Should I change for different headset probably?
Now it sounds okay.
Yeah, it could be a slight loose connection. Is it consistent now?
It's better, ma'am. Now it's better.
Okay, anytime during the, sort of session.
Yeah, we'll alert you. We'll alert you if we don't hear you.
Sure. And also, Deepika, I think, it might help with the bandwidth if I probably, when I share, is it okay if I turn off the video or do you reckon?
Sure, that won't be a problem. Yeah, that won't be a problem. You can turn off your video. Yeah.
Okay, sure.
So.
So do we start now? I think we should start because.
Yes, sir. We can actually. We do.
I'm just waiting a few speakers to join, and I'll just waiting for them. Can we wait for 2-3 more minutes and then start?
should we begin?
Yes, Deepika, we should start now. It's about time.
Yeah.
Yeah.
Start recording the session. You haven't put it on record. Okay. Warm greetings to everyone and welcome back to the third and final day of the VIT CIAT International Webinar, Technology for Architecture Futures. A big thanks to all the participants who have been with us for the past 2 days, listening to all the presentations and engaging actively in panel discussions. The theme of this session is Digital Technology for Future Cities, where we have 6 panelists speaking their perspectives on the given theme, followed by a panel discussion, which is to be moderated by Dr. Michael Karasowicz. Before we proceed to our session today, we extend our heartfelt gratitude to CIAT for playing a key role in identifying resource persons and making this event successful. We have a 2-minute slideshow on CIAT, its purpose and members. Please allow me a minute.
Which integrates architecture, science, technology, and engineering, and focuses on performance and buildability in design. Architectural technology encompasses a range of different specialisms, including conservation, sustainability, BIM, environmentalism, fire safety, and many more. Technology is leading the change in the built environment sector, and the Chartered Architectural Technologist is the professional with the skills necessary to drive this change. The Chartered Institute of Architectural Technologists, or CIAT, is the qualifying body for the professional qualification and protected title of Chartered Architectural Technologist. It is a not-for-profit organisation which sets and maintains the standards of education, practice, and professionalism in architectural technology by awarding professional qualifications, applying its code of conduct, ensuring members undertake continuing professional development, and accrediting qualifications in higher education. Those studying and working in the field of architectural technology and related areas are eligible to join CIAT. Benefits of joining and qualifying with CIAT include having a global voice to represent you, professional recognition, access to CPD events, professional and social networking, mentoring, and more, which can be found on architecturaltechnology.com. We offer an international subscription rate to those based outside the UK and Ireland, and these rates are shown on the slide. We recommend you take a photo of this to consider later. Student membership is free for the duration of your course. For more information, please visit the website for the requirements or email international@ciat.global. Global demand for architectural technology professionals is increasing all the time, and employment opportunities are growing. CIAT is working hard to develop its international network for its members and its collaboration with similar organisations worldwide. Please follow CIAT on its social media platforms. And for more information, please contact CIAT's international department at international@ciat.global. Thank you.
Thanks to CIAT team for that slide presentation. It gives me great pleasure to introduce the keynote speaker for the day, Ms. Geeta Ramamurthy. Ms. Geeta is the Operations Director, Vice President Digital at Atkins, India. She is a tech enthusiast and evangelist who is focused on driving technology adoption to enhance client value and business performance. She excels as a cross-functional change agent, spearheading data-driven decision-making, fostering a culture of experimentation, client centricity, innovation, and value creation. Being the operations director, she is now responsible for leading business and design transformation to support and deliver cutting-edge technology across UK and Europe, Middle East, Asia Pacific, North America, and Canada. I welcome Ms. Geeta to deliver the keynote address.
We can't hear.
Ma'am, you're not audible.
Yeah, just give me a second.
Yeah, it's audible now.
Okay, thank you. So can you hear me clearly now, Vidhu?
Yes, very clearly.
Thank you. Apologies for that. Thank you, Deepika, for your kind words of introduction. I would be extremely grateful to CIAT and VIT for giving me this opportunity to share my experience in terms of how technology is playing a key role in driving changes in the architectural sphere within the context of the AEC industry. As someone who comes from the corporate world and as someone who's been part of this journey over the last 15 years as part of this company called SNC Lavalin, and Atkins being a huge part of it, it is our endeavor not only to drive adoption of technology in everything we do, but equally, we're also partnering with industry and academia in driving this change. So now I would like to bring up my slides. Vidhu, can you confirm if the slides are visible?
Yes, ma'am, they are visible.
Thank you. So first of all, today I would talk about the AEC industry and technology. What experiences have we seen?
Ma'am, we again lost your voice. Geeta ma'am, are you there?
I think we lost ma'am.
No, she's there. I can see her name on the.
Can you hear me now?
Yeah, we can hear you now. You have to reshare your screen. I think it got disconnected.
Okay, sure. Sorry. Is it visible now, Vidhu?
Yes, ma'am. It's visible now.
Okay. So I would essentially talk about what are the emerging trends in AEC industry and technology.
Can you go to presentation mode, please? Got to go to the presentation.
Sure.
Full screen.
Yeah, is that better?
No.
No, ma'am. It's coming in like a
I
document
don't think
mode.
it's a PPT. Yeah.
Okay, it's a PDF. It's a PDF.
Maybe full screen is available. View under view or something.
Control L. Control L is for full screen.
Ma'am, try Control L, please.
Yeah. Just give me a second.
That's if it's a PDF, but it doesn't look. Yeah, there it goes. Oops, she lost it.
Sorry. Are you able to see the screen at all?
No, ma'am.
Ma'am, we could share for you if you like.
Yeah, can you please do that if you don't mind?
Okay, just give me. Is it visible to everyone?
Yeah.
It's
full view. That's it.
Ma'am, you let me know when I should change the slide. I'll keep doing it.
Yeah,
Deepika, can
sure.
you do a full screen?
Full screen.
Oh, sure. Control L, right?
Yeah. Yeah, perfect.
Okay, thanks. Can you go to the next slide, please? Yeah, so I was just mentioning that, I would like to focus in the next few minutes on the emerging trends for future cities, of which I would like to talk about the smart city technologies that we are increasingly seeing playing a huge role in changing the way cities will actually process information and make citizens a part of this endeavor to make, the livability much better. I would talk about how IoT and big data are playing a huge role in changing the way we are managing assets and how assets interact with one another. We also would talk about how standardizing content and reuse of design are now becoming more common, absolutely common in many of the departments that we are seeing, in many of the industries we are seeing. And there is some work that we're already doing as Essential Atkins in this area. Increasingly, we are also starting to see examples of generative design in architecture. And some of the early examples are really mind boggling. There is also an element of offsite manufacturing that I would like to touch upon, and 3D printing finally to close off. And so if you can move to the next slide, I would like to start by explaining that, pre-pandemic, what we've noticed as far as the construction industry is concerned is McKinsey's, much famous report talked about how construction, particularly as a sector, has been, the second least digitalized, just above agriculture. And we've often debated about what is happening with the sector and why is it very slow to adapt. There's always been issues with productivity, high fragmentation of supply chain, and losses have been mounting over the years. So now what we're seeing, the pandemic has actually forced many industries, including construction, to rapidly change the way they involve technology in driving this, delivery of as cities and assets. And what we're seeing increasingly is that architectures, engineers, contractors, and suppliers are now working more collaboratively digitally, and it all happened, by force. So if not for the pandemic, many industry experts as well as researchers have and observers have noticed that, if not for the pandemic, this change might have happened over a few years, if not, a longer time frame. But now the pandemic has forced people to think differently and actually adapt to the changes. That's one thing that, really is driving rapid digitalization. We're also seeing a consolidation in the industry, and we are also seeing, a lot of disruption going on where newer players, not necessarily coming from the AEC industry, the architectural engineering construction industry, are disrupting the space. So partnering and ecosystems are increasingly becoming more relevant. And last but not the least, we are seeing a rapid drive towards standardization and reusability, in the run up to adoption of tech. So if I just move to the next slide, where, I would like to talk about what are the key smart city technologies that we are seeing evolving in the last few years. Essentially, I think most of you would be aware that Internet of Things is starting to play a key role, where, smart cities are using IoT devices, such as connected sensors, meters, to analyze data. And if you take the case of, for example, smart utility meters, there have been companies that have started to use this in a test case where they're starting to connect multiple systems together, be it in terms of smart energy grids or the distribution, systems, or the metering systems or the infrastructure that's required to actually engage with the wider network to understand the energy flow, identify patterns, analyze what it tells us in terms of usage and costs. And it is starting to play it's becoming a game changer in the way of helping companies and even smaller building associations to look at managing this energy efficiency more effectively. We're also obviously reading a lot about smart transportation and connected vehicles. So here again, there are multiple elements within smart transportation, like, intelligent traffic signals, which again have been, ag- again, these have been tested in some parts of the globe. We're looking at smart parking systems as well, starting to make inroads. Ride sharing is now commonplace even in countries like India, and the data that, for example, Uber, for example, is able to get through the ride sharing can be used to actually understand, where the usage is more, and what are the peak timings, and what are the sort of not so peak timings, what are the price points at which these services can be varied. So data is becoming even more powerful with smart transportation. We're also looking at how this can ease traffic pain points, because essentially, if you're able to really understand the congestion areas and the congestion points and the timings, then effectively you can provide more advisory services to consumers, to customers, to actually be able to leverage these data insights to plan their transportation during the non-peak hours or during the times when congestion is less. This can also help prevent accidents on roads and deaths. Again, I mentioned about smart grids earlier, and smart waste management is also gaining ground. And I mean, I've really come across an example where one of the companies in US is actually using IoT to track the routes of where these garbage is getting deposited, and which are the best pickup routes are being suggested, and it actually essentially helps make the whole process more efficient and enable recycling in a much more coordinated manner. There is also increasingly a move towards using smart air quality monitors, and this again is starting to become more relevant as we start to see pollution creating a lot of issues for people, both in terms of health and in terms of other ramifications, in terms of assets and things like that. So I think in all of these areas, when we talk about smart city technologies, fundamentally there are two things that are common. One is technology, and the other thing is how connected they are, and obviously the data insights that these are able to generate. So if I can request you to move to the next slide. So I did talk about Internet of Things and big data, and essentially it is just an extension of what I mentioned in the earlier slide. What we are starting to see is that there are companies which have already started to leverage these technologies in some shape or form. So we hear of particularly companies in the oil and gas industry have been the earliest to adopt these technologies, be it Chevron or Shell, and they are starting to gain operational efficiencies in the way of using this data more meaningfully and being able to take proactive measures to manage their assets as well as the utilities in a way that it reduces the operational cost, reduces the downtime, but actually also helps to maximize the reliability as well as the efficiency. So if you can move to the next slide, Deepika. So I would like to talk about one particular use case where a major Australian road authority wanted to bring in some level of understanding around their radio management systems. So what they realized was when civil construction work is going on, they need to ensure that the radio performance is absolutely sound and in good condition. It's able to remain connected across the works during the duration of the work. So they used remote secure 4G modem, where they were able to use cloud-based platform as well as a SCADA system Stratus to actually assess if the road conditions were being closely monitored, if the workers were very much on the ground, and whether the radio systems were continuously working, because all of these are required to ensure not just the fact that the communication is always on, but also equally ensure the safety of the civil workers on the site. So it's small steps, but clearly we are starting to see greater adoption of Internet of Things. And in the case of Essential Atkins as well, increasingly, whether it's Asia Pacific or the UK, there are asks coming from our clients to look at how we can embed some of these new technologies to help them manage their assets more effectively, because capital is becoming scarce, and increasingly there is a push towards asking about what is the value companies will get by paying X amount of money towards an infrastructure spend. So that's where these are becoming more and more relevant in the context of architecture and engineering construction industry. If you move on to the next slide. Yeah, there's another example here which is very real. So BASF, being one of the largest chemical companies, in their Texas plant, they chose to deploy IoT and big data. What they did was they actually looked at 100 condition variables for monitoring about 63 of their substation assets. The aim was for them to use this IoT enabled devices and the mechanism, as well as a data driven system, to see if they could continuously monitor the condition of the assets and spot if some degradation was going to happen in a proactive manner, whereby by using the data analytics they would be able to not just look at what's going on in real time, but from the patterns that emerge through the learning, by machine learning, by using algorithms, they were also looking at predictive analytics to potentially look at threats of asset failures that could happen in future. Now, this started off in October 2020, and it will be some time before they are able to capture enough data that will inform, their decisions. However, there is a belief that, the early pilots suggest that they will be able to save a very significant amount of money through, this process in terms of reducing the asset failures and breakdowns. And they're estimating, anywhere in the range of 30 to 34 billion over a 5 to 6 year time frame across all of their assets. So this is very significant. And so these are not just concepts which we are talking in a wishful thinking way, but these are very real, and these are very much being used by some companies that are early adopters of new technologies. So essentially this helps to improve plant uptime and address the issue of productivity in the sector, which is what really we're talking about. And last but not the least, also ensure the safety of everyone involved. So if you can move to the next slide. I would like to also talk about one area where Essential Atkins is playing a key role. So as a leader in the engineering and construction industry, Atkins is really at the forefront of looking at standardizing design components. So we are looking at finding ways in which we will reduce reuse. We will reduce repeat work or rework. We will try to standardize the design components, be it in terms of the components that are catering to a highway construction or railway tracks. So on a range of such assets, what we're doing is looking at the design components and trying to understand what are the elements that need to be put in place in terms of adhering to the standards, making sure that they comply with ISO 19650, ensuring that the components have the right geometric information, the right level of information required from a manufacturer's perspective. All the metadata is embedded such that these components can be reused, and these are continuously maintained by a team of people. So we don't need to redo the entire design the next time we do a design of a similar highway or a similar railway track, but at least 30 to 40%, if not more, of the design work can be simply plug and play, because you're going to reuse the existing components and then you can add the bespoke elements. So standardization and reusability are again going to be quite significant in the way forward, as I see it, because these will play a huge role in certain sectors, particularly like modular housing, for example, or schools, where repeatable designs are going to be the order of the day. And this technology as well, or this application of technology, will lend itself very well to a system where you're looking at offsite manufacturing, because the lead time taken to come up with the design can be significantly reduced whilst maintaining the quality, accuracy, and consistency of design. Sorry, I think there's a slight right. Okay. So if you can move to the next slide. So yeah, thanks. So here I would like to talk about how generative design is again, gaining ground. This is an example of one of Autodesk's Toronto offices, where they use generative design to come up with the final, preferred design which they wanted to use to construct their office. This essentially involves looking at multiple options by the use of algorithms to, look at the preferences of the users. And in this case, in the case of this building, the designers consulted, a number of employees to understand their preferences, and they then input those parameters into their generative design tool. And there are, quite a few tools now that are coming up. They used a tool called Project Discovery, and it gave them multiple options to choose from. And eventually they chose one option, which was, kind of liked by most of their, target audience. And then they used that to finally, construct the building. So the point here is that with the technology, like an artificial intelligence gives you the power, to rapidly prototype, look at multiple options, test the outputs with the user community, and finally come up with the most preferred option, which in the traditional route would have not happened at all, in the manner in which it has been done. And secondly, it would have taken a huge amount of time for a company to do that. So this is another disruption that's gaining ground. Again, some early examples are what we're talking about, but increasingly we think that the future will be defined by such technologies like generative design. And I think I have a couple of more slides, perhaps. So if you can move to the next slide. Yeah. So I mentioned about offsite manufacturing. So here again, we are very closely working with Langeroog in some of our large projects in the UK particularly. And Langeroog has got a massive offsite manufacturing facility in Nottinghamshire. And their main output is precast wall panels, but they're also able to produce some bespoke outputs. So they have started to apply this technology in a couple of large projects, essentially in the buildings and even in the water and environment domain. The key benefits that they have started to see is obviously the speed of production, because you can really assemble the components, as I said, and if you have the design that can be reused, nothing like it. You can actually get those components very quickly put together, and these can be completely lifted and shifted to the site. And this not just helps with the speed, but also reduces the cost of build, brings up the issue of highlighting that sustainability is, again, can be something that can be kept in mind by using the right materials. You can also reduce disparate designs. There's uniformity in build, and you can reduce waste. Fundamentally, I think this is something that's going to become a bit more commonplace as we move forward. For us, we are seeing even in the Middle East, there is a huge ask for design for manufacture and assembly as a concept. Some of their large property and build companies are clearly, moving in this direction. There are projects that are being discussed about where they want the consultant and the contractor to work together to, really deploy this technology. So again, they're talking about AI, they're talking about, design for manufacture, they're talking about multiple technologies, including big data, because increasingly the ask is reduction of the cycle time and actually leveraging the resources we have in a more efficient and effective manner, as well as being able to provide human-centric designs which will be more fit for purpose for the consumers and users. So I think the next one probably is one of the second last slides, if you can move to that. So 3D printing, again, we are hearing a lot about it, but at least there are 10, if not more, examples that we have now come across of 3D printed housing, social housing, and the like. So this is an example of, a 3D printed social housing in France. And clearly, again, if you see there is a thread running through. So I talked about, repeatable design, standard design components. I talked about offsite manufacturing, and now 3D printing. I mean, if you see all of these, the running thread is really about technology and data. And so with 3D printing as well, innovation is happening where, they're using this method to extrude layers of polyurethane foam and then, bring in the third layer of concrete as insulation. And they are really developing these, houses. In India as well, I was quite pleasantly surprised to see that, a couple of days back, so there's an innovation that has come up here as well through IIT Madras, where 3D printed housing is now becoming a reality. So it is not theory anymore. It's not futuristic in terms of concepts, but it's really happening now, and it's proven that in some of the early examples, it reduces your cost at least by 20%, if not more, compared to traditional techniques. So these are some of the technologies which we have seen in various areas, and SNCL Atkins is very much intimately involved in some of these propositions. So that brings me perhaps to the last slide. So in conclusion, I would say that the future focus with all the technology trends that we're talking about in the architectural space will be pivoted on sustainability. And as I mentioned earlier, reduction in the cycle time. We are increasingly going to see a focus shift towards safety and well-being of people as well. And as I mentioned, human-centered design is a key ask we are noticing, particularly from UK and US, with a large emphasis on citizen and user experience. Of course, Europe has been one of the earliest in this space, where we did some work for the government of Norway to develop sort of a mini digital twin where human-centered design was involved. So there is a lot of disruption that is happening in this space, and it is quite real. Digitalization will certainly lead to some level of disintermediation and drive changes in asset building and O&M, because what I start to see is that digital marketplace and platforms will have a larger role to play. I mean, even today we know that for example, NBS is playing a phenomenal role within the building space, particularly in the UK, where they're standardizing templates, they're curating contents, and actually designers can lift and shift and pick and choose some of these content and straight away plug and play in their design. So increasingly we will start to see a lot of disintermediation in this space. Plus digital marketplace could bring multiple forces together by way of connecting the consultants with perhaps contractors in the not too distant future. And procurement models are bound to change with project 13 kicking off. I think that we will start to see collaboration being the order of the day. We will see that the labor intensive nature of construction sector could see a paradigm shift with some of the play of technology. Again, all of these are very real, and we got to be prepared for that change when it comes in the next few years. These will have implications that the workforce of the future also will need to have to be more relevant and fit for future, and to be able to build smart cities that really are pivoted around sustainability and safety. So on that note, I would conclude my session and hand back to you, Deepika.
Thank you so much, ma'am. It was a great presentation on the emerging trends for future cities. I'm sure there are questions, and also certain points that you mentioned could be taken up during the panel discussion as well. So the presentations by the panelists will be beginning now. I request all panelists to kindly deliver their thoughts within the given 15-minute time duration, so we get more time for panel discussion. The first speaker is architect Takbir Fatima. Welcome back, Takbir, to VSpark VIT. Takbir Fatima is an architect, educator, entrepreneur. She is the director of the interdisciplinary design and experimental architecture studio DesignAware. Takbir also created the Fractals Workshop and Buildaware. She has an MA in Architecture and Urbanism from AADRL London. Takbir was named Telangana Young Architect by the IAA and awarded the Emerging Architect of the Year by NDTV Design and Architecture Awards in 2016. Takbir is also a TEDx speaker and has exhibited her work and methods at various design events. Architect Takbir, you may please begin your presentation now.
Thank you, Deepika, and thank you, VIT, for inviting me for this event. I'm definitely in some really good company. So I would like to share different kinds of processes that we've been using in our teaching as well as our practice. So that's why my the talk is titled Technological Intent and Awareness in the Design Process. As mentioned, DesignAware is an interdisciplinary design and architecture studio, but it's not just a studio, it's also a kind of an incubator, which has given birth, let's say, to many other initiatives as well. Some of these I will be mentioning in the duration of this presentation. This is our studio. We're located in Hyderabad, as well as we have a workspace in Dubai as well. Of course, we're working at home now. Our studio over the years has been visited by students of architecture from all over India. Almost every month we used to host a group of students, but unfortunately, due to the pandemic, we were just like everyone else. We were forced to kind of rely on technology and shift to the virtual studio. We've been working remotely with a lot of our team being remote for a good 6 years now, with other team members being in different parts of the world. So this was not really new to us, but what was really positive in this experience was that we were able to connect with some really amazing people and also run a remote internship during this period. I believe that in order to make ourselves more tech aware and make the future of architecture more technologically driven, we have to begin with education. For the last 9 years, I've been teaching the Fractals Workshop, which is a generative design workshop that has been held in many different cities all over the world, and also online the last year. It's been featured in many different publications as well. That's our cover model there. So the premise of the workshop is that many minds and many hands can come together to create something that is much bigger than the sum of its individual parts. So to demonstrate, there are a few projects that we had worked on. This one was a very early project in which we were commissioned by Street Nights Dubai for the Street Art Festival to design an installation or public art piece which would be completely designed and built by the public. So how do you get completely, people who are not connected to one another to be able to come together and build something when they may be from different backgrounds and different age groups, and they may not have any design training to begin with. So we just designed this very simple, basic asymmetrical flat unit, which with grooves in it, which could interlock with other units, similar units, to grow in a very unpredictable manner. And then we sort of tried to predict how that would, one of the options that could come up out of it. There are multiple ways of putting it together. So computationally, we were able to predict that. And then we digitally fabricated the pieces in MDF, and we just gave it to the public and just told them to grab some pieces and start building. So this is, this kind of promotes the idea of collaborative design, where people from all different ages and backgrounds come together. It's a very self-explanatory process, very inclusive and collaborative process, and there's no right or wrong way of doing it. So over a period of 10 days, they were able to build an installation incrementally. Different people came and then added a few parts of it, and then over a period of 10 days, this kind of became a sort of collected or shared authorship and shared ownership public art installation. So every few years, we try to kind of revisit some of our previous designs, and we try to see what we could have done further to kind of take it to the next level. So this is a system that we started to kind of work on. Previously with the interlocking system, it was kind of random. So we decided that it needs to be, based on a set of rules, and then let's see what happens. So just by changing the rules and the parameters, we're able to get a whole range of different outcomes using the same, this is just one unit, which is being repeated. So it's a repetitive kind of, system, which has discrete units, which are coming together in a sort of dry construction system. And then you get a whole catalog of different, units. So it's a prototypical system that we are coming up with. So similarly, last month, before the situation with the pandemic was as bad as it is today, we went to Kerala, and we did this workshop at Kerala State Institute of Design for students from different design backgrounds. And you can see that they are creating their own, so they came up with their own basic unit, which is laser cut, and then it has all of these grooves in it, and then you can assemble it and disassemble and then reassemble it to get a whole range of different outcomes. So it's a prototypical system with discrete units, and then you can come up with different kinds of morphologies just by changing the parameters, and you get different outputs. And then they also translated that into computation and projected it to get higher resolutions and larger aggregations. And the last part of the workshop was to have a larger scale aggregation, larger scale units. So it kind of becomes almost like urban furniture of sorts. So this is one, and this is another example. So, and then we are exploring also remote build processes with our next workshops. This is another workshop that we had done for Hyderabad Design Week, where where the students did algorithmic designs, and then we selected one of them and converted them into, or translated them into, full scale and large scale and real material. So this is on permanent display opposite to the Telangana State Assembly in Hyderabad. At the same time, we were exploring this concept called the digital vernacular, where we design, we have this dichotomy of computational design as well as local material and craftsmanship. So we designed a series of installations computationally, and then this was the local material cane. So we used, local craftspersons and furniture makers to realize these. Previously, for Dubai Design Week, we had done the same hyperbolic paraboloid structure in Arish, which is the local material there, the date palm frond. This is located in Dubai Design District. And even prior to that, this concept actually was born in VIT, where we, at VIT Vellore, we used bamboo as local material, and we used the help of bamboo craftsmen to learn from them. And then the students came up with a whole series of about 8 different parametric pavilions. So we call this process programming matter, and this kind of was, this phrase was coined during my time at the DRL, when we did this design or this research during my thesis, where we used egg crates as a building material. So we proposed egg crates as a new technology in building, and when we add egg crates, instead of eggs, those aren't eggs, but ping pong balls. So when we add rigid elements to the cavities within the egg crate, it has a very peculiar geometry to it, and it tends to take different morphologies based on the programming of the matter that we're doing. So the way that we sort of manipulate or code the way the units are placed together would give us different kinds of results. So they almost become like control points. And the way that we bring the system together, it's a low-tech, high-tech system together, which we call a deflatable architecture, because we are actually using vacuum and deflating the system. And once you remove air from the system, these independent discrete units come together and they kind of become monolithic, and also they're really rigid, and they take on different geometric forms and curvatures based on the coding that is embedded in them. And once you release the air, again, you'll have a recyclable kind of system because you can redo it. So we decided the paper was kind of the most versatile material that could be used for online workshops, the Fractals workshop. And you can see the the analog models being translated to digital models, and then again to virtual reality. So here, this is a culmination of the student work from a workshop we did with the Boston Architectural College. That is Peter Atwood, the director of digital media, who co-directed the workshop with me. So what's really great in virtual reality is that it's completely free of real world constraints, like physics and gravity and scale, and all of these things. You can pass through the models, you can fly, and you can see things from different angles and different vantage points. And so this kind of becomes almost like a sort of virtual urbanism. So coming to our practice, we have a whole range of different projects from different disciplines to different scales, from wearable, digitally, fabricated wearable tech to a smart, accessible park for the city of Warangal in Telangana. So Le Corbusier said that a house is a machine for living in, but now I think that's kind of become antiquated, and I think a building is an extension of the body. So this is a project where we were asked to design a smart office for an IT and IoT company, embedding their IoT products into the building itself. So this is an existing building, commercial building, on top of which we had to design this sort of like a penthouse, and then the beehive kind of structure is the facade, and the undulating roof kind of, they become an envelope for the building. This is the evolution of the undulating roof structure, which is almost like an extrusion of the beehive surface. And we used some tools for analyzing, the daylighting and the heat gain. In a lot of designs, we like to incorporate traditional Indian architectural elements within contemporary spaces as well. So we have the courtyard, which even though it's on the 6th floor, we have this courtyard that kind of gives you this ground floor feel and makes it a green space. And then we have the jali, which is the screen, the hexagonal kind of beehive structure, which is the screen. And then the screen is sort of parametric in that it varies in depth in different places. So here you have some parts which are deeper, and they kind of become these isolation pods where people can sit separately and then work, and then there are spaces where people can work together as well. This cube that you see is a water tank that was existing on site, which couldn't be removed. So we converted that into a 3D sort of wall, a smart wall, which could have company-wide meetings, but also the IoT products that were embedded were able to gather data from the environment around this building and then project that, not just project it onto the screen, but also the building becomes like an organism that responds to the environment and the data that is being fed to it. So in terms of the lighting, as well as the temperature, and then the tinting of the windows, all of these things become responsive. And that's how the building situates itself on top of the existing building. And what's really great is that you can see the inside of it, which is really rare to see the inside of the top floor of any building, but the metro passes right next to it. So you would be able to see the inside of it. This is still, the construction is not started yet. And finally, this project is a residence in a very oddly shaped plot in Jubilee Hills in Hyderabad. So you can see that the constraint that we faced here is that we had a really heavy sort of programmatic and spatial requirements from the client, but the space was not sufficient, and we weren't able to do orthogonal spaces. And so these are some of the design explorations we did for spatial sort of distribution. And this is how the building kind of evolved, in which we kind of stretched the building from the top and then started to slice it to create orthogonal stepped kind of structure. So you can see that every level, it's like a series of boxes which are stacked one on top of the other, and there's an overhang of 3 feet at every level. And you can see that the ground floor is the smallest, has the smallest floor plate, and then it grows as it goes up. And what's great is that it sits within the bylaws and the regulations, because on the ground floor, you're supposed to have setbacks, and then on the upper levels, you can have a cantilever about 10 feet. So we're able to get a total of 9 feet. So where technology comes in is that the facade design is a computationally designed louver system of rotatable interconnected louvers, which are parametric in the sense that you can kind of rotate them at different angles to be able to create different percentages of openings, and these openings depend on the program within on the inside. So it's an openable and closable kind of system. So it's a dynamic facade which can be connected to the home automation system and also be controlled by a smart device. So depending on the amount of light that is required and privacy that's required, you would be able to manipulate and control the facade. Here you can see the overhang and some of the levels. So depending on the program, as I said, so some of the spaces require more light and more less privacy, and some of them require more privacy. During the lockdown last year, crazily enough, we started a new initiative called Build-A-Ware, where we take greater control over the construction process and the execution and fabrication process. So as I said earlier, it all begins from education. So in parallel, we started this initiative called Studio to Site, where we take students and young professionals to our live sites. It's a long-term program where we take them to our sites every couple of weeks, and they are able to kind of learn hands-on from the site itself, and they're able to learn through the construction process as well as learn about project management. So some of these classes were taken online. We don't just work locally, but by the use of technology, we're able to work internationally as well. So during our lockdown, which was in London, they didn't have a lockdown at that time. So we were able to design a restaurant in London while we were sitting in Hyderabad. So you can see our remote site visits that are happening on the left side. So we have done a lot of remote site visits over the years. And this is a much older picture of WhatsApp conversation between me and the carpenter for a school, a charity school that we designed in the Golconda Fort in Hyderabad. And what we did here was that it was a very participatory kind of design process in which we just created a modular system outlining the sizes and the the colors and orientations, and then we allowed the carpenter to take some design decisions. So this is what he came up with, and we think it's pretty cool that the carpenter has also contributed to the design process. The reason there are steps here is because there is rock. So this building was built on the side of a cliff. The school has kind of over the years become quite popular, and it was visited by groups of students from all over India almost every month. And then because of the lockdown, we couldn't have any visitors. So instead, I did a virtual walkthrough or a remote walkthrough of the school for the Virtual Design Festival for Design, which you'll be able to see on YouTube if you just look it up. And also, I think it's really interesting to note that the school was included in the Rethink Design Guide as a case study for architecture for a post-pandemic world, published by RIBA Publishing, RIBA. And finally, we are honored to have been longlisted for the Design Awards as an emerging architecture studio of the year 2020. We didn't win it, but I think being longlisted is quite an achievement for us. Thank you.
Thank you for that presentation, Dr. It was pretty fascinating to see how forms come to be by altering algorithms in a certain way and how they get translated into digital platforms and all of the building science elements coming into these forms. It was a wonderful presentation. Next, we have architect Joe Healy. Joe is a chartered member of CIAT and a senior architectural technologist with 16 years post-graduation experience in the UK, Middle East, and Australia. Joe has worked on a number of exciting and important projects over the years, with a particular interest in historical preservation and sports stadium design. Currently working in the architectural specifications field with a commitment to staff mentoring, which is documented in a book that is about to be released. I invite architect Joe to begin his presentation.
Hello, everybody from Melbourne in Australia. Hope you can hear me okay. Can I just get confirmation of that, and I'll share my screen.
Yeah, we can hear you, Joe.
Great. Is the volume okay? I'm not sure if I'm a bit quiet, but it should be okay.
Yeah, volume is okay.
Great. Okay. Okay, hopefully we're clear on screen now. Yes, my name is Joseph Healy. I'm a chartered architectural technologist with CIAT. As you can see, I was involved in the Middle East.
Are you sharing something?
Yes. Am I sharing?
We are not able to see.
All right. Let me share again. Sharing screen. Okay. This one. Is that a little bit?
We have it.
I should have my presentation on screen now, hopefully.
Yeah.
Yes.
Great. Thank you very much for that. That would have been a crucial step. Yes, my name is Joseph Healy. As I said, lead counsellor originally in the Middle East and Africa.
Full screen, please.
We'll see that. And now a committee member in
Can you
the...
convert into presentation mode, please?
Sorry, could you say that again?
Can you convert into presentation mode, please?
Full screen.
Yes, is that up?
Yeah, full screen. Yep.
Full screen. Sorry, is that up here somewhere here, I think?
No. If it's a PDF, just do Control L.
Control L, yeah.
Control L.
Control L. I'm on a Mac. I don't know if that makes a difference. So I'm not used to Macs.
No, it's the same on a Mac.
On view here. Yeah.
It should be Control L on a Mac too. Or I mean, not Control L, but whatever the button is on a Mac.
It's Command L, I think.
Command L, yeah.
Command L, yeah.
Is that a little better now?
Nope, didn't do it. Oh, where is that?
That should be better. I have it full screen on my screen, so hopefully that would be what I need.
Interesting.
Can you see my presentation on screen now? Sorry about that.
We can see it, but it's not full screen. You got the top sidebars going.
Right. Oh dear, sorry about that.
How does that work?
I'll stop sharing and start again, perhaps.
Yeah, that's true. It sometimes changes into another window for full screen. Do the.
Right.
Okay, there it is, full screen.
Yeah, it's full screen. Right.
Thank you very much. Sorry for that. Okay, I'll skip straight on to slide number 2. I was, as you can see, with my career experience, I had an architecture studies degree in Nottingham in the UK, and I've worked for a couple of companies there in Aldershot, just outside of London, and in London itself quite a few years ago. Within that company from 2007 to 2013 is where I achieved my chartered qualification with SIAT. And then, as you can see, working with Gensler in the United Arab Emirates, then also with Cox Architecture here in Melbourne, and now currently I'm with NBS in Melbourne as well, the specification writing platform. So the subject of today is obviously a very big subject overall. I think it in some ways leans away from architecture quite a lot in terms of discussing parametric design, and obviously CAD and BIM is a big subject where there's lots of capabilities. I think it's a lot to do with in what direction we're heading, which is kind of quite out of control, I think, in some ways. So I think with the pictures I have on screen here, you can see the one in the middle, for example, the Bird's Nest Stadium in Beijing. I think that's something that came from quite a clear concept, whereas the other two, I think in some ways you wouldn't be able to imagine that design in the same way without having things like parametric design to kind of set boundaries and therefore find designs from putting sort of algorithms into computers and therefore generating designs from there. So I think it's a kind of dangerous situation we're heading into, that we're obviously letting computers take over, which is quite strange for the future. So in terms of digital technology in future cities, I think there's a lot of variables which I've listed out here in very, very general kind of terms, as you can see. Lots of these are, have far bigger consequences and sort of far bigger realms that they dive into. But two particularly I'd like to talk about is the kind of intelligence that we have to analyze it and sort of understand what we need. And then the second question of, do we even need these things? So like I said, away slightly from the actual pure design of buildings, it's the sort of involvement of technology in our day-to-day lives and then integrated into our buildings that I've been starting to wonder, particularly over the last few years, how much do we need these interventions? They, as I'm about to describe, they can sometimes be positive and negative. So for a few examples, you can see the top two pictures there. So an old-fashioned bus stop. This may have been years ago, where you're sitting on a bench, you're at a bus stop and you have no information, you're waiting for a bus, simple as that. In our current situation, we're in a far more modern design of a bus stop, but we have so much information telling us about when the next bus is turning up, and therefore we're far easier to plan our lives effectively and know that information. That's undoubtedly a good intervention of technology. Secondly, an old hospital ward many years ago in black and white, compared to the very computer-heavy picture you can see on the bottom right. Of course, in essence, the amount of healthcare provision and our standard of healthcare has generally improved over the decades. But to me, that brings into question, and interesting to put this to everyone on the call today, to say, well, on the right-hand side picture there for the hospital, you've got a number of computer screens and all sorts of analysis going on, but would you prefer to have a computer looking after you whilst you're ill, or a person? And that's where I think the technology is really taking over to a point where we're just getting to a point where we need to balance. And coming back to my original point about what is the need for the technology that we're now inviting into our cities and designing. So similarly with the next two pictures, I think we can all agree that the emissions from automobiles around the world is quite bad compared to the picture on the right there with hydrogen cars is overall a really positive step. Far healthier for the environment, it's progressive design. It's then diving a little bit into the driverless scenario, which is having its issues, but you could say overall that progression of technology is helping. And the bottom two pictures there, a glorious picture of cycling off in the mountains, compared to the bottom right picture of you're still cycling, you're still effectively sitting on a bike, but you have that computer generated image in front of you. To me, that's an interesting one that starts to blend into travel opportunities, and therefore the way we design cities and the way that for many years we've been traveling around the world to see interesting places that we want to see because we want to experience them. Now, to some extent, if you have more of a sort of immersive view of that cycling route on a screen, to what point do you say, well, I don't need to go to the Alps in Europe or amazing mountainous regions to cycle anymore. I could actually cycle in my own house, have a big screen in front of me and get at least part of that experience whilst you're looking through a screen. So quite hypothetical. And I think you'd ask different people, they would have different opinions about the whole thing. But I think there's going to be a large proportion of people that would say, well, I can get an experience that is never going to be the same as the original, but it's not far off in some ways. So it's a massive kind of, I think, effect on not only travel, but the experiences that we have in order to actually go to places and see them for real. So we're having this fake version of the world that is based on a real, but it's doing such a good job that we can kind of take it as it is. So next two pictures, hopefully you can see there. Cameras at the top, obviously extreme levels of CCTV in our cities today. Generally good for kind of security and obviously being able to see what's happening in our streets. And on the right-hand side, in terms of crime, you're able to analyze the streets far better, see what's happening. This should help in overall reduction of crime and being able to kind of operate safe cities. So I think that's certainly where smart cities and safe cities are going. Oh, would you mind if I close this one? Go on back. And to the bottom pictures there, fascinating things I tend to look at on LinkedIn often is had kind of road laying and path laying technology with lots of automated systems there. As you can see on the left-hand picture there, it's the bricklaying computer. Now, it's an amazing difference from probably when I started my career around about 15, 16 years ago, that of course you have somebody standing there laying bricks. Now, incredibly, you have a computer there that's probably going to do it more accurately, potentially quicker, and of course, without somebody who effectively gets tired from standing there and laying bricks all day. So amazing intervention, again, of computers that you think, well, it's overall positive. Can't really deny that. But then again, it's taking away jobs that are manually skilled and therefore very important around the world. Suddenly, within a couple of decades, those industries may have actually been taken away completely. Then the bottom right-hand picture, we're looking at a sort of Amazon-type warehouse there, ultra automation, which I think is a fascinating and overall positive development. But at what point does that stop? You can have that almost dominating every single shop in your town centre. You just have the face of the company, and then everything that's going on in the background is all automated. Not really many people there, maybe just a couple of supervisors, in order to then bring products to the front of that shop. So again, we're potentially taking away whole industries, which I think is an interesting challenge to go forward. And like I say, it comes back to my overall point of what is the need that we are putting in front of ourselves? Do we actually need the technology that we're inventing? So a few examples here of staying in touch with the news, knowing that there's plenty of so-called smart cities around the world. of course, every city is doing their best to try and improve and sort of, I guess, apply the best technologies for the benefit of the people. But I think there's questions really as to whether that is always actually beneficial in practice. Now, I'd concentrate on the top example here, Singapore, whilst the other examples are still credible, of course. I sometimes find they're not overly helpful. They sort of sound quite good, but you think in reality, well, do I really need to know an analysis of the weather when I can kind of just look outside and say, okay, for the next couple of hours, I think I'm relatively sure about what the weather is looking at the moment. Then things like, for example, the traffic assessment, I think is really good because you're obviously able to see if a particular roads are particularly busy, and therefore you plan your movements around that, and hopefully the city works a little better. But as I said, the Singapore version up front there I find particularly effective, looking at crowd densities, movement of certain vehicles, and then systems monitor the energy use and the waste management. So I think the analysis is sometimes better than applying something to try and help people, but it doesn't necessarily help people as much as the original intention. So the analysis brings in the data, and therefore you can use that data to make real improvements. There's again some challenges there where I think the inventions and the innovation is brilliant, but there's just a question about sort of the intelligence that we're introducing to our lives and whether we really need it. So looking forward to the design kind of phase a little bit more. As I said, I'm working with MBS, so I'm into the specifications side of things now, with great integration there, particularly that we're using between models and actual specifications. So it's far better than it used to be in terms of that connectivity between your employees actually building up specs as you design. What I want to talk about on this slide is kind of repeatable cladding effectively. The two pictures in the middle there, you'd have to say one has followed the other, I think. I'm not sure you could have two independent people that would come up with that design without having seen the first one. Now, it's very interesting because I don't think that would come organically. I think that would sometimes, argue that it comes from parametric design, from being able to set out actual parameters of the facades, sizes, multiply that around the facades. It organizes the corner details for you. And that kind of storage of design that we have around the world, I think is now easier to copy. You see it on pictures, you know how it can be produced, and we're taking far more from what we used to design instead of innovation, which should be purely from your own imagination, purely from your own mind. The right-hand side pictures there, again, you've got a large kind of platter of facade designs, modular designs, different dimensions, different sizes and proportions. Now, once a company has built up a number of those, there's a point which they say, well, we have nearly all the iterations of a cladding design for what might be a typical 3.5 to 4 meter slab to slab level. At what point do we keep making new designs, or do we choose from a good trusted platter that we've had before? Now, again, that's the thing that's in some ways that's stifling the innovation, but it's potentially more efficient. There's a challenge there to say, well, what do we need? What do we want, and how are we actually getting there? So the bottom slide, in the same way, you have this kind of platter ahead of you that do you just choose one? Do you keep innovating what you've had before to actually stretch out pure design and design something new, or is it more efficient to take what you've had before? Certainly, from a client point of view, I think that might be the case. So a few questions I wanted to pose. Like I said, I'm fascinated to see previous presenters talking about parametric design, the actual software they're using to create designs, putting in boundaries and parameters for a design, and that punches out lots of options. It's fascinating technology and it results in great buildings. But I'm coming back to what we should be doing as a kind of on this planet, really. We have the chance to innovate, and we are doing so, but it's almost stepping back to say, well, what do you want the world to look like in 50 years? Will they all be copies of buildings from the past 50 years? So the top point there, I can say the power of BIM models obviously is incredibly useful for the most part. Is it lazy design or is it efficient? Do you take one from 5 or 10 years ago and say, well, we're basically going to use that one because it worked before, or we're going to sort of be efficient about it and say, well, we can use one of those and copy it again? It's a different challenge there. Interesting effects on design in terms of digital technology and actual progression of design. I could see in many years' time from now, I'd certainly like to look ahead to what the industry might be like in 50 years. I'm not sure staircases would even be needed in most buildings, in tower blocks or residential units, if lifts become so efficient and safe in the way in which they're managed and operated. I'm not sure you'd need staircases, because by then fire strategies may have developed that you can get people out or protect people for a certain amount of time in order to get them out in terms of going down the side of buildings as opposed to through the middle. So interesting developments there. Very common argument I hear is about concrete being very water heavy in its usage, but that's probably going to be superseded, I think, by kind of polymer technology. So we're replacing things because we have those options. We have to analyze whether we want them long term or not. So I would argue that one is a good development in terms of reducing all the excessive water usage. Buildings collecting and using their own energy. I think this is definitely a big step forward to come. All the groundworks that happen now in terms of drainage, sewerage, electricity and gas piping. Now, if a building can collect, obviously from solar energy, for example, you can collect water by itself, can it use most of those resources that it collects and use that for the building itself, and therefore effectively needs no connections to the overall district? So that's technology that's put in front of us, and we think, yeah, that's great. But there's a challenge there to say, do we want that? Do we want that independent sort of style, or do we want to stick with what we've got? Spending time in cities around the world, obviously there's a lot of tall buildings. So the second to last point there, spending weeks or months without being at ground level, I think is a really interesting concept, because certainly the more you have towers linked at high level, I think you could conceivably spend days, weeks, or maybe even months without ever going to ground level. Roof gardens up high on buildings, if they're connected at roof bridges, there's obviously going to be shops and supermarkets up at those levels. So if you can get sort of what you need as a human being at those levels, because you get the greenery from being outside, you can go to do some exercise, you have friends around in the building, you don't need to go to ground level anymore. It's a very interesting analysis as to what technology is starting to do to affect our design. And finally, surveillance and ownership of the camera data. You know, again, I sort of challenge everyone on the call here to say, well, we're far more under the camera than we were 10 years ago or 20 years ago. I think in 10 years from now or 20 years from now, there might be a case where as soon as you leave your house, you're probably in view of a camera for quite a big percentage of that time. Now, that's just carrying on because building owners and people keep buying cameras and they want surveillance equipment. But the more and more we buy it, the more and more that market succeeds, and therefore we're going into this world where we're potentially under a lot of surveillance. The two pictures at the bottom there are actually from my hometown, just north of London in England. There's these small, amazing little sort of robot units. They're openable from the top lid, as you can see, and they deliver groceries to people. So in a sort of next step on from online delivery of shopping, you've got these small units that they're apparently completely secure when they drive around the pathways and the roads, and they're controlled by GPS, so you can understand the company can understand when they have been stuck or something, or have lodged themselves on the side of the road. But for the most part, they arrive at your house. There's a small notification, and your shopping has arrived. So amazing technology. You think that's great, but again, there's ramifications there to look at and think, well, what is the need? So yep, I'll have to leave it there. It's probably more questions than answers, but it's a big subject that I think is fascinating to kind of project yourselves forward, ask what we're sort of doing with our design and what we're buying, what we're putting money into, because it's going to shape the world that we'll know it in a few years' time. Through the lockdown months and years, I think we've all been through that kind of pain over the last little while. I gradually and eventually have just about produced a book, which is a bit of an ambition over the years, called Building a Career in Architecture. It's particularly focused at architecture students, people who are interested in architecture from a young age, just to kind of flush out the early years in the industry from my experiences, what to look out for and what was good and bad. So my view on the industry there. might be helpful to some people here to hear my views. So it's nice to keep in touch with everyone here. That's about it for me. Thanks very much.
Thank you, Joe. It was great listening to you. The way you iterated the need of technology and the positive and negative impacts that it could have on the building design and on the cities as well. The questions you posed in the last few slides, they were certainly food for thought and probably could be taken up at the end for discussion. Thank you so much.
Thank you.
The next person in line is Dr. Bharat. Dr. Bharat Haridas Aital received a BE degree in electrical engineering and PhD in data mining, urban pattern analysis, and modeling from the Indian Institute of Science, Bangalore, India. His contribution to society, such as rejuvenation of Melandur Lake of Bangalore, urban crisis of India, its policy framework has brought him a great deal of appreciation and recognition. Dr. Bharat is currently with IIT Kharagpur. He has a whopping record of publications with 70 journal papers, 12 book chapters, 2 books, 100 conference proceedings, and 50 technical reports. He has delivered lectures in Indian academic institutions and R&D organizations. He is known for his work on GHG emissions, water crisis of Bangalore, trees of Bangalore that exemplify his field excellence. He is now working on digital data observatories for smart cities of India. Dr. Bharat, we are immensely grateful to you for accepting our invite. You may now begin your presentation.
Thank you, Sir Deepika, for a kind introduction. And let me thank VIT and Professor Vidhu for inviting me here. So last speakers who fairly gave introduction to what I am trying to speak about, but my idea of speaking today is something different from all these speakers in terms of I'm speaking about geospatial technologies. So all my previous speakers gave an idea about how these are integrated, but I would say that how geospatial technologies would bring these to cities and landscapes in the future connect. So the entire presentation I've divided into 3 parts, when I would give you some framework of how and what are the technologies that we are trying to speak about. Then I would give you some small analyzed output of some 1 or 2 cities. And finally, I would give what is IIT Kharagpur doing in terms of making itself smart. Okay, so when we speak about smart cities, the first thing that people think about is information and communication technologies. So that is actually a backbone of how an communication network starts. Then, as the first speaker who spoke about said about the Internet of Things, how sensors are connected and how the sensor interact with different entities. This part of it where it is generating data. But these data are entities unless you pick it on the ground. So it is the geospatial technologies which bring in the more connectedness where you can get the data with all the technologies and put it out and pin it to the ground. That is how geospatial technologies help. So when we are looking at smart cities, the first thing that I spoke about is ICT. So when I see ICT is nothing but you are generating a large amount of data. That data is being communicated in certain form of transactions. These transactions are stored in certain hardwares. So these hardware needs certain amount of softwares to connect among them, and that is how you look at now the most happening thing, which is cloud computing. So everything that you are interacting with on your mobile phone or any of those devices that you are electronically connected are mostly working on the cloud computing aspects and providing a lot of information, which is gathering hundreds and millions of tons of data. So this data, when this generated, this actually builds in a gap where it has to be analyzed quickly, and most importantly, present the real world scenarios. That's where your artificial intelligence come in. So that actually brings in the realistic aspect of how you can interpret these data and the real world scenarios. So this brings in, most interestingly, once you have analyzed this, but you need to look at how you put it on different automation systems, or put it in terms of the data that is readily available for any user to use it. So that's how the term Internet of Things comes. So this may have your embedded systems, this may have your sensor networks, this may have automation of buildings. So all these connected together give you something called as the Internet of Things. Then you have sensors. Sensors, it may be any of those sensors which actually build in a lot of data. So these are the part of ICTs, but these can be defined as a single group which is fueling data into the system. And finally, once you have all these data, you need some name scope to put it on the landscape. So that's how geospatial technologies have come into effect. So when we look at geospatial technologies, it starts with your satellites, to your radars, to ground surveys, to your UAVs, your drones, etc. So all these put together in a form of things that can be interpreted to land, it's nothing but your geospatial technology. So when we are looking at this, my definition of an smart city is nothing but it refers to an urban space that is ecologically friendly, so technologically integrated and meticulously planned, which is a particular resilience on use of information technology to improve efficiency. So now, whatever most of the countries are trying to do is either look at ecological part and integrate technology, or integrate technology in terms of planning. So if all of these are together, pushed in together, then probably we will have a much better future cities that can be more livable. So having looked at this, there was an Open Geospatial Consortium in 2015 which brought out what should be a component of a smart city, or let's say a future city. So as I described, you have the first layer, which is a sensing layer. You can look at different city sensors, the data that is crowdsourced, data that can be sensed out. It can be from your drones, it can be single layer data sets that comes in. It can be your satellite data sets. So these actually become some part of data that comes into the data layer, and then builds up into a business layer where you have a lot of catalogs, semantics, and visualizations. I'll show you some of these visualizations which we have already done. And this can be applied into various applications, whether it is health, whether it is public safety, whether environmental protection, urban planning, sanitation. So all of these can be done with this data. So that's how the IoTs are connected in terms of building more data from its own intelligence that comes as a backbone, where the computationally intensive intelligence can be built upon. So having looked at this, geospatial, what I pitch about is geospatial technologies are for future cities. It means, just let me give you some examples. So if you can see here in a particular video, this is showing you a terrain visualization and a heat map. So when I look at a heat map, it is easier to understand. It doesn't even take a few minutes for me to develop this heat map, because the technology has already been developed in such an extent so as to understand what is a heat map, what is the stress level in that particular region, particular building, and how can the stress level be addressed easily. So another very important concept that we have been hearing it, I think the youngsters are very interested with this, is geofencing. So geofencing, I hope you have seen in some of those cars that have geofencing. So it is how you actually protect your data, protect your, let's say if it's the car, protect your car from various things that it can be stolen, it can be embarked. So how it can be really put in a particular place without going into much of a distance. So we use the GPS signals to track it out at a particular radius. Post that, it will be completely under the data surveillance to the to the owner or to the, if it is connected to the police department. Then think that geospatial technology is actually is creating virtual cities through the virtual reality part. So wherein we are looking at how virtual reality can bring in more amount of planning, more amount of contextual information that is necessary for it to be utilized in the future. So similarly, if you look at some of these 3D city models that have been developed over a period of time, when we are looking at some of the spatial data that has been developed, you can easily understand the pattern of growth. You can look at how different peak models are here and what are the changes that is happening and what is the effect to the environment. So then going back, you can rig it back to how different entities are related to different things around you. So there's one very good examples. One of the speakers spoke about digital road networks. Yes, it is becoming a reality today. Wherein, if you look at even your Uber, Olas, etc., so they have a complete control of the digital road network. And if you can look at your, the best example is your Google Maps. So you know where is the real traffic conditions. How do you get it? It is basically crowdsourced data, which is pinged into understanding what is a crowd behavior and what is a vehicle behavior over a period of time. So that's how you get that. And in today's scenario, we see that the error is somewhere around plus or minus 30 seconds. So which is quite good in terms of the necessary options that are available. So then we have some of this one developed by United Kingdom Road Safety. So when they are developing a IoT platform in terms of looking at how this road safety aspects can be integrated in planning and looking at the behavior of the people around in this road. And let me show you a complete video. So this is how geospatial technologies are helping smart city growth. So whether it is traffic, whether it is connected lights, connected behaviors, as the previous speaker Joe spoke about the cameras, yes, it is, but yes, they are connected. You can always connect those data, put it in the public mode wherever it is required, but also the privacy of these data can be eventually improved in case that the government wants to do it. So yeah, so these are some of those. When you look at there's a particular jam in this particular region, so a person sitting at that particular place can easily look at what is the issue at that particular road. That's how the geospatial aspect is moving forward in this scenario. So coming back to the work that we did work on Bangalore. I think people who are at Vellore, they would be able to relate how the Bangalore, how it has grown over a period of time. You can see this is how a green city, what we call, has turned out to an urban agglomeration completely, which is quite unplanned. I'll also show you some thing that we did using some of the NLPs or deep learning techniques. So wherein we could, from the satellite data and the UAVs that we use, we could look at how we map trees across Bangalore, and it appears to be that we have about just one tree for 7 persons, and whereas the standards say that you have to have at least 7 trees per 1 person. So that's how it has been changing. So this is how geospatial technology can be used in order to get more information or data. So on your left-hand side, you can see these are the tree census that we did on the Institute of Science campus of Bangalore, which has about 22,000 trees. And when we looked at the remote sensing data using certain machine learning techniques, we could map out each and every single tree, which is clearly visible. So almost closer to 97% accuracy. So then we started relating each and every aspect of how this has changed. So if you look at the greenhouse gas emission, the very important part whenever people speak about greenhouse gas emissions, the first part they say is road transport is the major part of the industrial thing. But interestingly, when we calculate this, the domestic sector here was a huge contributor in terms of greenhouse gas emissions. So when we look at even that, why is that? If you look at planning in Bangalore, many of these houses that are built, or the buildings that have been built, are from a temperate. It's a copy paste of the temperate climate. Whereas when you look at India, it's more of a tropical climate, and it has to be in a different mode. So that was one of the major contributors that we could see in terms of why this was this was coming as a major contributor in terms of greenhouse gas emissions. And yeah, we looked at land surface temperatures. One of the speakers did speak about this. So most of the places where you don't have curvial or ultra-linear or non-linear reflections, so you have the dip in the land surface temperature, and the stress level is much lower. So we did across various cities of India, and you can see how the transition of the urban growth happened over a period of time. So this is one such representations, and we did visualize. See, that's what is a very important part of geospatial data, the visualization to your future scenarios. So that gives you the hold on what kind of data and what you are trying to plan. So this is for 2026, for what kind of growth and how much would be the urban growth over the period of time, and where it will grow. Yeah, so then, so along with that, so, when we are showing this, it's more of, we are looking at a linear patterns, but what people like to look at is the 3D part. So satellite data, especially the stereo data, gives you the more of a 3D information. So that is what we are trying to look at. One of my search scholars who has designed his own method in using a deep learning technique was able to understand what is the height of a building, what is the size of a building, where is the rooftop. So and easily extracted without much trouble in terms of integrating. So we are trying to automate this kind of a model over the large area. So we are trying to collect more information about each and every city. So yeah, this is what the model prediction says. It was quite accurate in terms, because we had an accuracy about 95% to the ground data. So having said this, just last few slides, wherein what is IIT doing in terms of this? Where the first thing that we did was, when we are looking at all of these data, we designed kind of report that is to how we develop a roadmap in terms of developing an urban observatory, which means it is a connected IoT system, and which is collecting data and analyzing data on a real scale, and how it can be actually put to use. So similarly, we had even the legal and policy perspectives, where Joe was actually speaking about. We detailed out what are legal issues, what is the policy interventions that we have to have, and what are the kinds of privacy issues that may come up when we are developing such observatory. So we did do it with British Deputy High Commission located in Kolkata. So yeah, so we are also putting out all this data into a particular website, and this particular website would be accessible to anyone who wants to look at this data, analyze the data, and also someone who doesn't have a computational power to basically analyze such data can do it just with a single data that is on this website. So we have also developed a complete IoT based lab at our school at IIT Kharagpur. So this is what we call it as a smart campus. So it is a test bed in terms of developing a smart city. So wherein we have geotagged cameras, we have we have a lot of sensors, of almost 22 sensors, and the sensors that includes UAVs, the temperature. I'll show you some of them. And these have four different verticals in terms of analysis, real-time analysis, and data-driven approach. So yeah, this is what is that lab. So these are some of those. So we this is how we communicate. There are sensors, there are drones, And if you see, these are certain cameras, air quality monitors. We have GPS across the campus. Yeah, so these are some of the communications that we made wherever we could intervene in terms of what can be done to the society. Yes, that's it from me. Thank you very much for giving me a platform.
Thank you so much, Dr. Bharat. It was pretty enlightening to see how data analytics, computation, and automation play a significant role in creating our future cities. Thank you, sir. I think Ms. Kavita is not online at the moment, so we will go ahead with the next presenter. Our next presenter is architect Vamsi Krishna. Vamsi Krishna Vemuri is a speculative architect, entrepreneur, educator, and researcher based in Germany. He operates in the intersection of speculative design, immersive media, and real-time visualization. Having been an active educator conducting workshops, webinars, and lectures across Europe and Asia, he co-founded Futurely, a globally accessible educational space for advanced architecture and design. Through their research studio, FluxReal, they have developed various speculative and experiential architectural projects that have been exhibited in various platforms and design conventions across US, UK, Germany, Latvia, India, and Japan. I request architect Vamsi Krishna to begin his presentation.
Thank you, Professor Deepika, for the wonderful introduction. So let me share my screen. Just give me a second, everyone. I hope you have, you see my screen.
Yeah, it's white at the moment.
Yeah, it's blank at the moment. That's right.
Okay.
Yeah. Now I hope it's clear. Yes, perfect. Hello, everyone, and thanks for having me here today. Special thanks to VIT and CIAT team for this. So I'm Vamsi Krishna from Futurely. My presentation is about the virtual and the hybrid fields, as you see it here. So let me begin by unpacking some of these terms. So primarily, I'm going to keep it super light and super simple, because most of my work and the presentation that I'm going to show you today is something to deal with the emerging space that has been getting created in the recent years. And especially, it's becoming a lot more significant during the pandemic. So when we set aside some of the conventional architectural constraints or the urban constraints that we usually see in the field, such as the structural integrity, the materials, the feasibility, and the conventional financial models, even the environmental responsiveness, we can dive into this new layer of space that has been evolving exponentially each day for all of us to take charge of. So there's an immense opportunity for architects and designers to leverage the potential of the space. I already think that you get a glimpse of the terms that I'm about to use here, and we will dive into it slowly now. So one of the things is, as much as we talk about and we are interested in the architecture as a discipline and the interest in built environment, my particular focus area deals with the digital layer that encompasses the built environment. So before we proceed, the model of the stack, this is a diagram by architectural theorist and architectural and political theorist Benjamin Bratton, which forms an underlying foundation of my presentation. So this model serves as a literal and technical prototype of how different networks collapse and overlap. Different network architectures operate between very small and large scales, and how a large set of stakeholders engage with it. So thus he calls the stack as the accidental megastructure for a geopolitical architecture. On a lighter note, while we are talking about these new fields, and these fields are getting overlaid and superimposed into our physical environments through the medium of virtual, augmented, and mixed reality, I think even today and the past 2 days during the conference, I'm sure you've heard so much of these terms. So I will keep it super short and give you a brief variation or brief distinction between these three terms. So one of them being the first one, the virtual reality is a completely disconnected space from the real world, something similar to movies such as the Ready Player One or some other popular media. I'm sure science fiction has a lot to offer in terms of virtual reality. And then we have the augmented reality paradigm, which is an overlay on the real world, which is accessible through your mobile phones, like through apps such as Google Lens and Pokemon Go, the most popular game in the recent years. And mixed reality, on the other hand, is a slightly more advanced version of AR, augmented reality, where we are able to interact with both the physical and the digital elements at the same time. So think of it as an augmented reality layer, but a lot more responsive to the environment. So what I'm going to show you is an amalgamation of these fields, these technologies that they create, and the new spatial conditions that are formed through these. So to begin with, when we deal with this field, it operates at different scales. So I will briefly walk you through the scale at which most architects and designers operate at this point. So which is, they use this space to harness tools of design, communication, and even as an aid for fabrication or construction. So some of these available tools let you sculpt, design products, interiors, and even create architectural spaces. This disrupts the whole idea of how we interact with the interface, and this creates a new spatial possibilities to architects, where we can perceive a sense of scale and proportion, even be able to interact when you see it and react and respond as well. So it expands not only to there, and it expands to a space of collaboration where you can collaborate, iterate, and take real-time decisions on design or on constructions, and even on your BIM models. So at the scale of a city, when you see it, this is where the AR or the mixed reality part comes in. And the spatial interfaces start to create a new overlay where we interact not only within the bounds of our screens, but also engage with the space all around us. So think of it like a spatial interface that's all around and spread across the city. I think overall, whatever I'm talking about is kind of something that builds upon all the amazing knowledge that was given to you by the previous speakers. So I'm showing you how it feels like, how this sort of technology, when it's in place, the application looks like. So our surrounding context and the city becomes an interface for new interactions. So this begins to change how we perceive urban spaces, streets, and landscapes and buildings. So as a final example of how we utilize this medium as a tool or an aid for design, we can see it through this example of hologram, where architects and engineers could use this as an aid for bending complex assemblies and fabricating structures real time on the site using spatial data. And there are certainly plenty more possibilities. So with that being said, what I'm more interested in or more focused upon is the way these fields provide an architectural space, a space for operations or social and communal interactions. We see a whole emergence of social and interactive spaces, communities, workplaces, and entertainment, all accessed through this technological hybridity. I think that's a lot more evident since the pandemic. So the intimate spaces around us transform in scale to a much larger interconnected field that simply cannot be neglected by us right now. Because we are all prepping up our avatars and stepping into these spatial social platforms such as AltSpace, Mozilla Hubs, where we can carry our personas through distinct avatars and interact, collaborate, and even have events together. Probably the next conference by VIT would be in a virtual platform. You will never know. So the scale of these spaces is constantly expanding and evolving into their own, in the form of a city, in the form of a country, or it's much larger than that. It's much more global at scale, because these things derive from the digital and they derive from the idea of social media. So we are talking about billions, millions and billions of users that are coming in and flocking into the space. So having said that, now let us take a look at the expanded arena of gamescapes. This is what you see is a sample of the map from the video game Pokemon Go. It was something that was popular in the past, in the couple of years ago. And it had expanded into our urban scale, urban context, where predominantly through augmented reality, and just presented as a scenario where you actually have a lot of elements, digital elements that are scattered across the city, and it lets you interact with these. And the game also create an overlaid point of interest through these various points in the city, where you actually read the city from a different perspective. You have monuments, you have sculptures, you have important locations in your city that are being translated and transformed because there is an alternate story, alternate history that's being overlaid upon. And it simply doesn't end there. The users interact and engage with this alternate map of their city, which is not just an overlay, but rather intersects with various roads and arteries, creating its own navigation systems and social modes of interaction. And they even work together and creating these maps. So this is how you can collaborate and communicate. And it's really fascinating because your conventional city is performing, and it has its own activities and the variables that it works with. And then you have this overlaid, superimposed layer that creates a whole new perspective. So such a framework is not just limited to entertainment. So this is where I'd like to bring an example of an experimental project. And one of the things that I always do is, since I'm a speculative designer, so I try to create these experimental scenarios and see how it pans out when we present it, or when we see this technology in action. So that's how we try to construct these scenarios using the digital tools and immersive media that we have today. And how do we have a person's lifestyle? How do we see a person's activity with these kind of frameworks in place? So let's assume that this sort of a framework is there. And I'm going to talk about briefly an app called Focus, which is an AR augmented reality based educational system that is gamified based on the Cedric Price's idea of Pottery's Think Belt project. And it has a lot of modules, educational modules that are scattered around the city. And how does one person just briefly navigates and collects these modules, consumes this information while they're traveling? And how does a lot of new overlays, how does a lot of new, when your notifications, when your messages are all spatialized, how does it look like? How does it transform? That's what I'm interested in. These are just brief snippets that I'm fast forwarding. Right. So with that being said, last year we kickstarted Futurely. It's an initiative that was conceived during the pandemic. And as Ms. Deepika introduced, I have been an active educator, but not from the institutional point of view, more from an external point of view of conducting short courses, workshops, and events. And we thought that we have this opportunity to bring this all online and reach out to a lot more people across the world. And having said that, and that's how we started Futurely last year. And we started conducting a series of events. It's just not me, and we have my partner and a couple of other instructors from all around the world. And we were exploring different ways of how these spaces are created and perceived in virtual reality. So to begin with, during the last year Digital Futures event, we began to question the idea of workspaces and how do they transform in the virtual. This project attempts to create serene characteristics from a temple within the virtual workspaces. I'm going to quickly run through because I believe we have a shortage of time. And while in another project, it was a virtual adaptation of Hyperloop transportation system, a transportation system that was conceived by Elon Musk, and how it can operate, or how can we simulate such an apparatus in the virtual space with the conveyance and transportation as a means for dynamic workspaces in VR. Some of the key questions that we explored include the materiality in VR, the modes of navigation in VR. And this is another project which is a museum prototype in the form of a virtual experience where it's an amalgamation of generative algorithmic forms in conjunction to historic elements, cultural historic elements. And as we see, the project embraces these systems and it creates a space that is interspersed with these two layers. And how do we navigate these spaces through different gravity conditions, different non-physical constraints that we get in the virtual? And beyond the conventional architectural conditions, this is another project that attempts to create a miniature planet through an alienated landscape filled with portals and teleportation mediums of circulation. So we begin to question how various circulation systems that we know in a two-dimensional manner of plan and sections can transform into a gamified virtual space. So with that being said, this is my final project that I'll be showing you today. We explored with the photogrammetry strategies of documenting a small town in Greece using drones. The captured data, because of the machinic imperfections, is fragmented and it comprises of chunks, discrete chunks of the actual space. So these discrete chunks have been rearranged and stacked in the virtual medium, and it attempts to showcase the essence of the actual town, the historic essence of the actual space in a more digitized manner. And you see a new version of this city that emerges from this whole exercise. So to summarize, what we saw is a glimpse of our ongoing research and exploration in the virtual and hybrid architectural and urban scapes. What's really interesting is that we are presented now with a medium that aids us with the process of creation, and it also expands in scale and becomes a space of inhabitation. So we are now having the opportunity to design using the spatial media and also to design for the spatial media. So these new spaces are constantly changing, evolving, as opposed to the long-lasting nature of architecture as we know it. Thank you.
Thank you, Vamsi. That was indeed captivating to see how these tools and technology like AR, VR, and MR makes one create and visualize spaces along with the sense of scale. It was a wonderful presentation. Thank you so much.
Thank you, ma'am.
The next speaker of this session is Dr. Jonathan Scott. Jonathan Scott is a fellow and chartered member of CIAT. He lectures in architectural technology, responsible for the studio delivery of the architectural technology course at the Robert Gordon University, and lecturer in stage-built environment. Jonathan has worked in research and teaching in the areas of environmental design, energy monitoring, life cycle analysis, social and occupancy evaluation. Jonathan has undertaken a PhD on optimizing the relationship between passive solar design of new housing and the economics of construction and land value in the field of environmental design, creating a decision-making tool for the selection of detached homes. Dr. Jonathan, you may please begin.
Thank you very much. Thank you very much for that introduction. Hopefully you can all hear me fine. over here in sunny Scotland as it stands. Thank you for having me. I'll attempt to screen share right now. Okay, here we go. Again, thanks for having me. That was a fascinating introduction by Vamsi. I really enjoyed that presentation. I enjoyed all the presentations today. My presentation's got a slightly different angle to it. I'm talking about my course myself a wee bit. I'm a course and the kind of emerging technologies that we're adopting for our course here in Scotland. Like I say, it's from an educator's perspective. I'm not doing as much research as the preceding presenters here. By any stretch of imagination, like I say, it's been fascinating to see all the presentations previously. But as a school, as I'm talking about mostly today, and the course itself, a lot of research is input into the teaching that we undertake. Like I said, I'm Jonathan Scott. If you want my full kind of title with all my letters and affiliations at the end, it's not been updated. It should be an FCIAT there, not an MCIT, but that's me. But generally speaking, you can call me Johnny if needs be. That's what my students and my colleagues call me. And like I say, the course we have here at RGU, which is a Centre of Excellence. You've had presentations from the other three, and I'm the last in line here. Is at the Robert Gordon University, if you don't know where that is, which very few people do. It's based in Aberdeen in Scotland in the UK. This has been me for the past year, educating, researching, talking to colleagues. It's been a strange thing to call this a city, really. It really has been my city this past year, indeed. The novelty is certainly worn off. I do look forward to teaching again back and doing research back at our campus, our lovely campus in Aberdeen. But I'll give you a quick overview. I know we're short of time. We're one speaker down, but we're also behind time. So I'll try and keep this short for you all, so you can have a more discursive event after this. But I'll give you a quick overview of the course. It's slightly different from the other Centre of Excellences in that we have 4 years. Well, we take our students. There is a point to me introducing this. I will say that I'll get to it towards the end. But all students in architectural technology have these kind of 4 aims, certainly in my head. It's about gathering information, thinking about it, critically thinking about it, analysing it, sketching it, and drawing it, whatever form that drawing is. We've obviously had quite a lot of digitisation, hence the name of this session, I suppose, but we do hand drawings as well. Certainly in our younger years, but it's not a linear process. And in this industry, in this industry of architecture, nothing ever is simple or straightforward. It's a problem-solving exercise, so it's normally a cyclical process where you have a project or an idea that you gather that information for. You critically think that information, sketching, draw it up, and fundamentally you get it wrong about 50 times before you get it right, if you ever get it right, or the closest fit to whatever the client's needs are, or the project brief if it's in the academic sense. And that's reflected in our course. This is actually my course in a very neat diagram. It's a journey with some core modules and some ancillary modules that kind of fit in, and it kind of adheres to a number of different criteria in Scotland, but the fundamentals of it is the technology modules in our second, third and fourth years that bring in the foundations of quite a lot of what has been talked about today, fundamentally. I will kind of bring those into stage 3 and stage 4 predominantly. But I just wanted to introduce this to illustrate that it's a journey for the students, and for a Centre of Excellence, it's very much a journey from undergraduate to postgraduate as well. We have postgraduate courses that our students go on to. One of which is Advanced Architectural Design, which talks about quite a lot of the stuff that Vamsi was talking about. So it kind of feeds into the one to the other. That was very quick. I said it would be quick, hence the slide. But I'm happy to discuss the course or myself or my ideas on artificial technology in more detail. If you need it, you can just give me an email. But getting to the point of this session here, I kind of teach the three technologies. I think we've got a lot of students and a lot of ideas and a lot of perceptions about artificial technology in the UK. And I think a lot from academics' point of view, the traction arguably is the architecture and the title, but not necessarily the technology. I certainly sell the course on the technologies. And there's three broad technologies I sell the course on, and I think is relevant to future cities, or ever more relevant to future cities, to be brutally honest. And these are building technology, sustainable technology, and information technology. Building technology is our bread and butter. It's how things go together. We focus on buildings and we understand the buildability and construction, and that's changing. That's modernizing for future cities exponentially so. Sustainable technology, zero carbon agenda nowadays, changes in approaches, and I think this will probably be emphasized by professional accreditation by CIAT in future, very near future as well. And certainly it's what my PhD was about. It's what I'm interested in. It's what my research predominantly is on. I've been involved in Zero Heat House up in Scotland, and a whole plethora of assessment tools and sensors have been utilised in a number of buildings that I've been involved with. And also information technology, or digital technology, if you want to call it that. I tend to avoid the word digital because it's all about information and relaying that information. So I think that's the more important word personally, but take that as you will, really. But there's kind of no kind of hierarchical structure to any one of these technologies, and fundamentally the perfect technologies, if it does exist, blends all three technologies together. I'll probably build technology because it's the core. I'll put that on top, I suppose. And this, if you want to take this as a pyramid type structure, it's not supposed to be, though. They're all equitably important, and the perfect technology is utilizing, from an educator perspective, for sure, the digital technology angle, the sustainable technology angle, and the build technology angle. But in terms of what's happening in the future and the kind of research that we're doing at RGU, I've kind of cut that into these kind of three areas, and it's a kind of exciting time for digital technology, if nothing else. I think I think it was Gita, or maybe it was Takma that kind of mentioned that it's an opportunity for change. This kind of COVID world that we're in, we're kind of been forced into it, almost kicking and screaming in some instances, into the change. From an educator's perspective, some things we will probably won't go back to, lecturing in the kind of normal format, but it kind of applies to research as well. And like I say, all these kind of areas is what staff, if not myself, are involved in at RGU, with the kind of central tenet in the middle being still the perfect technologies, but also building information modeling, and that as a hub to bring all these things together. And if you kind of, while I waffle on here, if you're kind of looking at all the different headings here, I think all these boxes here, all these little lines, all these titles have been ticked off by all our different presenters. And I would wholly endorse what has been said this morning. And from my kind of perspective as a course leader and a centre of excellence is how this research and how this information is educated and relayed back to our students. And hopefully we've done that fairly successfully in the past 2-3 years, and we'll continue to do so. But with a kind of example of that adapting and that kind of thinking is to show examples of students' work and the kind of projects that we've led in the past couple of years. I don't expect you to be able to read this. This is just a presentation board by our students here. After 4 years, the students get a full year to interrogate a project brief. And it is tackling all those kind of key issues, those sort of future issues that we've all talked about. Well, this afternoon for you guys, it's still morning for me. In this instance, the project brief The two examples here are the same project brief, just to show that the students can go off in different directions, but they were developing a new campus building on our campus, which is a kind of greenfield site, almost a brownfield site on the edge of Aberdeen, and building a new building that would reflect the future of RGU and kind of building that would be utilized in the future. And in this instance, this student is looking at a test bed facility for prefabrication of different elements from art all the way through to construction, engineering. We're quite a strong engineering background here at RGU as well. So it's given opportunities for community learning as well, for students to learn at their own pace and test ideas, product design perhaps as well. And it's future adaptable as well. In this instance, the students are looking at benefit the site itself. It's kind of long street, taking in the view at the end there, but also having these blocks that plug in and play can be changed over time. So they're very flexible and adaptable building within itself. One of our presenters was talking about Le Corbusier. I think the idea of a machine for living was very much in the student's mind when he created the design. As a technologist, you can see that the building technology comes into play, and the sustainable technology. This is a zero carbon building as well, and the digital technology is also at play in this instance. Same project brief, but this student was looking at it from a cybersecurity point of view, with the Internet of Things being an important part, and how that might play into the design of buildings in that sense. So you can already see that the students are taking off different angles, different ideas. They've got that flexibility and adaptability in academia to test these ideas, and what that means for architectural technologists, and what it means for them to design something that's fit for the future, adaptable for the future, and zero carbon as well. But still kind of fundamentally adhering to the tenets of building technology being the core of an AT. And yeah, I kind of stuck to that 10-15 minute remit. So hopefully you're happy with that and that introduction. Happy to answer any questions in the next session if there's not another presenter.
Sure. Thank you so much, Dr. Jonathan, and a brilliant time. It was wonderful listening to you with all the different technology streams that you mentioned. With also you had mentioned about decentralized work patterns, which certainly seems to be our future, working not just decentralized, but also in remote. It was really good to see your students' work as well, incorporating technology ideas within design. Thank you so much. The last speaker for the session and of our 3-day event is Ms. Kavita Mohanraj. Kavita is a design entrepreneur specialized in the field of computational design, 3D modeling, and advanced manufacturing. With over 12 years of experience in designing and product development and 8 years in the field of 3D printing, and driven to empower the use of technology in creative industries. Kavita loves to explore the intersection of design, technology, and manufacturing, creating an innovative interdisciplinary platform that embraces values of digital age and its diversities. Kavita is an ambassador at Women in 3D Printing, a global network which promotes, supports, and inspires women into additive manufacturing. I welcome Ms. Kavita to share her thoughts.
Hi, thank you, Deepika. Let me just share my screen first. Okay. So yeah, today I'm going to be talking about my journey, and also try and also tell you how technology played an integral role in the development and what we are doing in our company now as well. And I'll also try and see how the last part, I wanted to try and tell you what are the things that are happening right now also. Since I'm trying to keep it as precise as possible. So if later there's anything, you can approach me for it as well. So I think my introduction is given there. Like I'm Kavita. I actually I'm the co-founder of a company called Into Design. I'll be explaining what we do there in a little while. But again, to just add on, I'm an authorized Rhino trainer and a Grasshopper trainer, and I do quite a bit of 3D printing, and I'm also an ambassador for Women in 3D Printing. In the next slide, I'll probably explain. I wanted to give you through my journey on what we do in our company and what has happened throughout the life and how technology mainly has impacted in the way my travel journey in architecture was as well, or I would say in the construction industry. Right. So in 2008, I passed out, became a Bachelor's of Architecture from School of Architecture, Anna University. Then I think for 4-5 years, I kind of worked in and around in India. Then I did my master's where I did on a subject called Advanced Architectural Design, which was more into, how do you work with data. And I slowly I knew what I wanted to become. I wanted to become more of a design consultant. And so I kind of geared myself into, kind of mastering into software that will help me to work with data, which is like Rhino, Grasshopper, Python language, and also other plugins that will help me to work with interactive dimensions as well. So these were some of the things that I worked with, and 3D printing was always a part of my part of my life, I would say, because it's almost been 10 years since I've been in the field. And slowly at the end of like around 2016, I wanted to also get myself technically well versed. So if you give me a printer and ask me to repair, yeah, I will be able to mechanically repair it, and I would also be able to develop the design and design for printing as well. So that is something that I really love in my work. And slowly what happened was still today, the last part that you see, which is design for advanced manufacturing, is what I am specialized in and what we give it as in our country as well. We do quite a bit of design for manufacturing, for 3D printing, and for composite manufacturing as well. We started off thinking that we would be giving majorly services for architecture, but then we realized that this technology was not just for architecture, but it kind of runs parallel. There was a lot of requirement in automobile. And I think you guys already know that jewelry is one of the most biggest industries in India, and that required a lot of our services, robotics, architecture, product, and medical industry. So these are like the places that we work with. So it's like one day you sit with an architect, another day you sit with a doctor and help him, kind of facilitate his design. So that is the kind of journey we've been taking in our company. And this is just to culminate what we do back in our office. So we do computational design and advanced geometry consultants. And definitely industrial design and development is a part. We go in even as a design facilitator. Say you have a design, how do you make it ready for manufacturing? Particularly our specialization comes in with 3D printing and with manufacturing, that is particularly FRPs and fiber polymers and so on. And prototyping is another key aspect where we develop it for 3D printing, 5-axis CNC milling, and so on. So when all these are there, we definitely love to give our knowledge back. So we do quite a bit of knowledge training, not just for students, but also for companies, where we go in and, kind of spearhead their team in terms of what kind of software and what kind of technological needs they need to understand. So this is generally our ecosystem of how we perform. And this, I think, generally, it will be together with most of you all as well when you practice this as a general requirement. But what I wanted to tell you was how in this particular setup, which are all the different technologies that you can, or technologies or softwares, what you can use via in this process. So that is what I wanted to kind of tell you. And while I'm in this process, I would like to mention that most of our projects are a bit of an NDA. So I will be explaining certain parts of the project. And this is one of our one of the very first projects that we worked with in terms of manufacturing, that is composite manufacturing. And why we call it advanced manufacturing is the entire setup, what I'm going to show you in a while, is going to, it was completely manufactured via machines, and there was no human intervention, not much human intervention apart from operation of machines, right? So this is the, we were given the commission to, kind of develop the design and also develop the manufacturing drawings for this particular interior cabin. And it was quite complex, the entire process. We were also one of the few architects, like I think in an entire room setup where there was electrical engineers, instrumentation and control, lighting consultant, mechanical engineers. So there was a lot of data coming in for us to design this particular space. So all we had to do was collect the data, analyze the data, and refine it first of all, so we could design that particular space. So, and apart from it, another very key important thing was how do you design for composite manufacturing, which is again a very key parameter here for us. So slowly, once we got the initial set of parameters, we started developing. And another key thing is it has to be a generative design. The reason why it has to be generative, or let's say, once we are done, there might be a lighting control person who will come in and say, and this particular space, you need to change something. So we had to keep all the parameters set right. So we took the help of Grasshopper and another Rhino and Grasshopper, these softwares, to kind of make it generative in a generative model where the parameters could be easily malleable. So, so the first step was to kind of give them. So this is with the government as well. So we have to give them a lot of options to come up with. So give them a key initial idea, but that idea is not enough. In here, in this particular project that I'm going to explain, and why I took to explain this also was I would say 80% of our projects, we don't deliver a 2D drawing. It is all about 3D model, because these 3D models are directly sent into machines to start building the final construction. So our interventions are mostly with computers and not with a contractor who is going to do a hand weld or so on. So what was important is once you conceive the idea, how do you prepare the model or prepare the design for manufacturing? So that was the most crucial step, which was our concern as well. So you need to kind of think of panels. What is the best way you can what is the first panel that is going to be assembled? What is the second? What is the third? So this is another, just a half part of the inner interior of the train. Again, this is completely with FRP, right? So this is again a little bit more of the interior shots of how we kind of conceive the idea. This is actually train 18, Vande Bharat. So the first thing that I showed you was the interior of the train. This is the train, and the inside is what we were working with. There were quite a bit of, the minute the engineers, or I would say the officers, wanted a very liquefied organic design. So we created an organic design, but then finally what happened was there were also other limitations such as the instruments that was used on the dashboard. So that you would notice that from where, though materially, construction-wise, it is possible to create a very organic design, something like what is here, but there were limitations in terms of the machines that they used. The machines were still a little old. So these kind of on-site limitations are also there, right? So this is our way of, kind of creating. And again, just to point out, this particular project, there was no intervention of any 2D drawing, only 3D model, which was done in terms of panel, sent it to the manufacturing industry to develop it. So this is one, and we've been quite consistently, we've been working with ICF, which is in Chennai. We help develop the design, and we also sit in with the engineers to develop the design further as well. So this is another train. So the last one, this one, I think probably the first time I'm showing this outside. This is the train 19, and this, I think it's almost on the platforms now, which is Vista Dome. It's another train. It runs in the Araku Valley. So this is another one. So most of our thing is about the designing of the interior of the shell, and the exterior is done by the in-house team of the factory. And apart from it, yeah, we do quite a bit for the automobile is probably our major sector right now currently. And this is another project again with FRP. Whenever you're designing, I think all of you know this is an electrical vehicle charger. So when we had to design this, the two things that the company these days, it's very, very important for any company to create sustainable manufacturing. So in this particular design, there had to be only two pieces, one which was the outside and one which was the inside. So how do you optimize for design for manufacturing? That is a very, very important thing, apart from designing a piece. And of course, we do quite a bit of facilitation for architects and designers. We help them facilitate to build a complex geometry, to give them an idea, not to just give them an ideation, but to develop the model for manufacturing. So we tap with quite a bit of architects to help them doing that as well. And this is again with the medical industry where, you kind of grab the CT scan data, and whenever this is for a wrist fracture actually, where, for every fracture, the mold is actually fully air packed, right? It's like a vacuum. So what these guys did was, in this company, they wanted to create a pattern inside which the airflow and the movement of air could be well versed. So, but then every time for them to create a pattern or customize a product and 3D print, the end product is actually 3D printed. It was a little difficult for them, right? So instead what we developed is we developed a Grasshopper script with which they could insert just the CT scan file, and it will give them the final model, which has to be 3D printed. So this is the kind of, again here, no introduction of any 2D paper print or anything that is required. It's file to factory. That is what is done here as well. Very similar. The last one is 3D printing, but this is laser cut. It's a hand sling. Again, it can be customized as per an individual's hand. So they scan the hand and then they sling. But this is a scan. This is just a sling, so it can be adjusted. Again, this is laser cut. And so this is again, our medical interventions. We work quite a bit with doctors as well. But again, most of them involves patents. So I'm just showing you the outer thing of how we, kind of help them develop. This is one of my personal favorite projects as well, because what happened is this entire project, starting from design to end user manufacturing, has been done in a 10 by 10 feet room. So that, again, the reason why I want to, kind of showcase this as a very personal favorite is the power of manufacturing in your own hands. So what will happen to the entire city, right? Particularly, another thing that I really wanted to add here was during the time of COVID, there was these face shields, right? So we ended up 3D printing those face shields at home, and then we started supplying. The very first of April 1st, there was a lot of requirement of face shields. So that was the time, again, we could feel that the power of manufacturing, particularly when you have it at home or in your studio in a 10 feet by 10 feet, that's called decentralization as well. So the way 3D printing will change or revolutionize the manufacturing or the construction industry, it is going to be tremendous, right? So this particular project was designed, I would say, like in an hour time, and then it was developed in Rhino, and it was 3D printed with a 3D printer machine, which is desktop machine, which is called Ultimaker. So the entire process was done in 1 day, right? So that is the power of manufacturing here. And today, what I wanted to majorly tell was the power that you have and the way things are changing tremendously, particularly in the scope of design optimization and manufacturing. So that is a very, very important thing. And as architects, I think we should try and embrace it. And there is a lot of scope, which again, that is the reason I also wanted to tell the journey, because I just wanted the rest of mostly the students to know that when you are an architect, it's not necessary that you have to only do an architecture project, but there is a scope for a much more diverse field, particularly when you start specializing in things. So these are the three very important departments where there is a lot of scope. And I just wanted to also, kind of put in what are the different ways of the different plugins that we've used in all of these projects that that I've showed you, and how we kind of use technology in each and every part. So one other thing is, which is a major, there's a lot of misconception towards technology, which is we think that technology is for making, but for me, they have been tools for thinking. There's a very famous thought of Mario Capo, which I would like to point out here. And these are the primary tools which will not just allow you to think, but the way you produce, the way you realize, everything will change, particularly when you start using technology. So all we need to know is to use it in the right manner or in the right limitation and scope. Right, so this is quickly to kind of tell you what are the different ways of data collection. Particularly, we were talking about city today, so I thought I'll introduce things like OpenStreetMap. I've personally seen a lot of people sitting and plotting for an urban design project or a part of the city. They keep plotting and then tracing it from Google Maps. That is not necessary, particularly when you combine something called ELK, which is a plugin. You can just extract information into a 3D model directly from OpenStreetMap to here. So these are simple tools that you can start using. Particularly, this is another plugin called Mosquito, which you could use to extract information, which we use quite a bit for our clients as well. If they want a certain set of data, we try and extract that data. This is, say, for example, there are 100 people in Beach, and if they've checked in via Facebook, you'll be able to retrieve each and every information of whether they are their gender, their age, their name, and so on, right? The basic general information that is available for public. So usage particularly for data collection, usage of these plugins will help you to sort and refine a set of data, particularly when you work with humongous number of them. Right. Again, when it comes to ideation, I think most of our projects particularly have been on the side of public domain. So we try and use user-centric design because of the universal category, age group category as well. So UCD is something that we kind of work together with. And when the geometry gets complex, we tend to use the software. We embrace Rhino quite a bit because it helps us to, it's a file to factory software where you develop the design, you can directly send the design file to the factory, right? So we kind of embrace that software quite a bit. And particularly, I think for 3D modeling and for optimization, when it comes to sustainability conditions, you have quite a bit like Gecko, Eve, Rain, and so on. And particularly this is Rain, which is fascinating because we've also tested this. You can simulate the way the water is going to come down the roof, right? So these kind of optimization, how the volume of water that is going to come and so on. So yeah, so this is a pretty cool plugin when you think of optimization. Optimization is a category where there is a lot of specialization that is required these days as well, right? So the last one in this particular thing is prototyping, which will help you to kind of refine your thoughts, make your end user understandable. Say for example, you're not prototyping, we could go in for VR or AR where you can let the client understand. Like since we work with a lot of engineers, for us, instead of kind of making a paper print of a render, we prefer to show them via Lens, show them via virtual reality that this is how the train is going to look, which makes our life very, very efficient and for them as well. So adapting those while in this stage is a very, very good trick. And perfectly, I think manufacturing wise, there is a lot that we can speak about. I can speak about this for 3D printing for another 1 hour, but considering the time, all I want to just, kind of wake up with was to, kind of speak about how robotics is going to, kind of change construction industry. I think day before yesterday or 3 days back, IIT at IIT Stavasta Group has already built a 3D printed house. I think most of you would have had a look. If not, you can just type IIT Madras 3D printed house. You will notice that there is quite a bit of developments in India as well. When I speak about robotics, I don't speak about the robo machines that walk around, but I'm speaking about the ones that can help via construction, right? In this case, how it understands the coordinates and helps you, kind of get the precision in Jali wall or so. Or other things like how Boston Robotics has developed, or where this particular dog-like robot can walk around in a site and understand the site survey. It can correct you if somewhere there is something wrong, right? So in terms of surveying, it is a really good work. And another thing is Volvo has also been doing quite a bit of these dump trucks, which can be robotically controlled, right? So that is another crucial development in terms of robotics as well. The way construction industry is moving right now has actually been compared to the last 5-6 years. I think this particular year, from last year to now on, I think there's going to be a completely drastic change that we are all going to witness. So we might have to be, kind of ready for the impact. And on the left, this is again, partially we can be, it is a robotic 3D printing as well, right? So this is something that they proposed to happen in Mars. So these are different robotic manufacturing that we have to do. The reason why I kind of got into it is to mainly tell you one point, that it is very, very important for us to understand what is the brain, what is the file that you need to give to these machines. You need to understand the machines really well and help develop that particular design to prepare these kind of models, right? So I would like to end the entire presentation with these two thoughts, that automation and digitization is the future of construction industry. And one thing that we need to really think is the way we think, way we realize, and way we produce. These will be definitely impacted when automation and digitization is going to, kind of revolutionize. Right. So all for today, it's all about how we should upskill and adapt to change. I'm Kavita. Thank you.
Thank you so much, Kavita. That was really brilliant to see how technology involves in fabrication, the examples that you showed with the locomotive and how you use tools like Grasshopper, and also the tools you mentioned towards the end, which will certainly be useful for students as well. Thank you. Like the one you mentioned, ELK, it will certainly be helpful for students as well. Thank you so much.
Thank you so much.
I'm extremely happy to introduce our moderator for the panel discussion today, my colleague at VSpark, Dr. Michael Karasowicz. Dr. Michael has a technical diploma in architectural technology in British Columbia, bachelor's in architecture from the University of Oregon, and MSc in advanced architectural design from GSAP Columbia, New York. The recent research led to a doctorate in technical sciences at the Academy of Fine Arts in Vienna. The research is in studying the intimate connection of spirituality and architecture, which inevitably becomes a study of technology and its role in practice and our concept of what architecture is and its evolution. I now request Dr. Michael to take over for the panel discussion.
Good afternoon. I guess you can all hear me. I'm pretty used to this. My mic almost always works.
It does. We can hear you.
I really appreciate all the different input today. I think we've got a huge range of topics that we've touched on. We were kind of focusing a little bit on the future city, digital information in the future city, but it's also advanced architecture. But you can see the scale actually comes down to kind of harnessing or harmonizing all the different ideas about technology that we've talked about today. So I'm going to try and frame a kind of a view and then ask some questions of I think there are 5 speakers are left right now. So let's see how this works. So we've talked about accelerating technology. That's what we've heard. It's accelerating very fast. And so we talk about architectural technology, and sometimes the question of architecture is kind of superseded in terms of just we're talking about technology, and it's applied in the realm of architectural practice. So I can think about it in 2 areas: is application and the tools we make. Tools are technical, digital, and they're in development, and it's really fun and exciting to make these tools. And the other question is the architecture and how it actually works with architecture and how it actually defines architecture. And there was one comment from Vamsai where he said, quote, evolving as opposed to technology, like all of this technological stuff, as he was talking about, VR, AR, MR, is evolving as opposed to the long-standing nature of architecture as we know it. As we know it being like a parenthesis, almost like, uh-oh, what's going to happen? But we'll get to that. So there's the question of, I'd like to focus on this kind of link, because a lot of the presentations were about what was being done and all this newness and evolution in the technology. And, you know, the real link to the environment, say urban environments and architecture, was maybe we can flesh that out a little bit better in this panel. So one of the things that's happened is that the pandemic kind of defines in a very visceral way that our human environments are not doing us very well. You know, there's a lot of talk that this pandemic wouldn't have happened if there wasn't so much tension and stress that we give ourselves in our environment, right? That we would be healthier. And so we treat ourselves pretty much the way we treat our wild environment, the natural environment, which is fair, I guess. It's a certain equality between the destruction of the human environment and the ecological environment. That's one way I'm poking this panel here, by saying we are actually destroying the human environment more than we're building it. Similarly to the global environment. We're not proceeding very well there. But at the same time, at this period in the pandemic, as has been said by most people, it's enhancing the communication aspect of technology very powerfully. You know, communication is starting to, technological abilities in terms of us being able to communicate with each other is moving forward, primarily through forced adoption, right? We're forced to use it. So we start to inhabit it better, right? And then Zoom gets really, really rich and starts to make its platform even better. You know, they were the lucky ones, weren't they? So I guess I'll start with kind of like Geeta's presentation, and I was thinking about how to control the conversion of all these efficiencies of speed and all the different powers that are coming right into the everyday corporate world, and specifically how we can think about it coming down to making the life and the environment of the city better. Most of the talk has been, with Gensler, it was about speed, 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 right? Everything's faster, right? And that is somehow supposed to convert into, well, actually a better bottom line. But in Geeta's presentation, there is this kind of thing like, okay, you're producing elements in the world. How can we be sure that the 20% efficiency somehow translates to the environment rather than just profit? And so I would like to ask that question of Geeta. I was going to ask it of Dr. Bharat as well, but he's gone away. I would like to ask Geeta that question, and then afterward, also Jonathan or Johnny, to ask him, because he's in the educational field, and in a lot of ways, what he's doing is allowing people, to translate that or teaching people in that realm. So I'd like to ask that of Geeta and Johnny.
Sure, John. Thanks for that, nice summary, and also, a very pertinent question from you. So from what we are doing in SNC-Lavalin and, Atkins, in terms of looking at, how these technologies are really shifting the paradigm in the industry, and what does it mean for us as an organization? Yes, it talks about, positioning ourselves as a competitor, which is ahead of its competitors in the space. And it looks at, how can we enhance our shareholder value, no doubt. But increasingly, some of our priorities are shifting towards the ESG space and towards sustainability. So I think, for us as a business, if you ask me, in 2021, right from top to bottom, there are 3 priorities of which, sustainability is very big, which means, looking at the environment, how can we consciously measure, how we are progressing on the carbon footprint. And we're calling it engineering net zero. So we engineer net zero, towards that future. So it's a priority for all the leadership, but it doesn't stop at the leadership level. It gets pushed to, the person who's sitting at the, sort of the junior most level, to recognize that there is a responsibility we have in everything that we do, whether it's producing a design or, engaging with a consultant or a contractor to provide the right inputs. It's challenging ourselves on what can we do better in the realms of sustainability, because if you separate it out from what you want to do in terms of using new technologies, it's not going to serve the purpose. So for us, I think the differentiator is embedding sustainability and initiatives like net zero as fundamental to the way we will deliver our business. So to that extent, when you pair it with new technologies that are clearly creating those opportunities for efficiency and productivity enhancements, I think we have a game-changing plan in place. So that's really the way we are going about, Jonathan, and I believe that this will actually help us move the needle on multiple fronts to help our bit, to do our bit to contribute to the environment.
Okay. How about Jonathan? Johnny, are you there?
I'm here, yep. I hide my screen when it's not in use. Yeah, I think my PhD is on environmental design. And one thing that struck me when I was looking at that PhD and all the research that's involved was the importance of or how important the architectural world, cities, and the connections humans have with their buildings and their spaces around the buildings. And I think with over the past year with COVID, that's been quite well expressed in terms of accessibility to green spaces, mental health, as well as, and I'd cover the entire spectrum of sustainability includes mental health and our mental health inclusively. So any kind of designs that from an educator's perspective, any kind of project brief that I develop would always ask the students to test their designs against sustainability and against healthy homes and providing healthy buildings from in that context, be it nowadays with digital technologies, but also from a fairly practical sense as well, given that it's an undergraduate course, it has to be quite hands-on too. So absolutely critically important would be my kind of short answer there, Michael. It's core to what we do, form over function, I would say, but I just emphasize it has to be function over form, and these two digital tools can aid that process from an educated point of view. Not sure if I answered the question. It was quite a broad question. So
the question was intended to focus in on, that there has been, this word of acceleration and intensification of digital technologies, and since was little, it starts out with the Jetsons, that this future is coming, and I'll tell you now, as I'm reaching the last third of my life, it never came. It's not coming. It's not coming in the West in a lot of ways. I mean, we don't have that leisure life. We don't have that ease of production. And whenever there's a new version of Photoshop, our work just increases. It doesn't reduce, right? Every version of software just makes us have to do more in general. But okay, I'd like to ask Vamsi a version of this question. At the very beginning of your talk, you mentioned something about the conventional financial space in such a way that I kind of had the intuition that you've thought about the financial connection to what I was asking the other two about, the conventional financial space also is one of the contributors, first of all, to technology, where money is made on microsecond transactions, and it kind of completely becomes virtual reality, right? The financial world is virtual reality, and yet finance defines building to such a huge degree, right? It's finance, especially when you have a boom cycle rather than a bust cycle. So I was wondering if you have anything to add in terms of that finance aspect, and if you've thought about that at all.
Okay, I think I might have a limited, limited perspective here, especially when it comes to the aspect of finance and the built environment. Of course, my work primarily relies on the virtual space. So what I believe is, to your question, I think the degree of finance is how it kind of creates a variation. For example, with the technology and with the level of automations that we are going through, the companies or the infrastructure is becoming smaller and smaller, and the production and the efficiency is growing larger and larger. So there is a lot of cost optimization that a lot of construction companies could do, or the whole construction industry as a whole can engage in utilizing these and optimize their costs, so thereby reducing the financial burden as a whole. That's how I see it. And just taking it more towards the virtual side of things, the amount of material usage, the amount of impact that it has on the environment has a lot lesser impact as opposed to physical construction. Mm-hmm. Yeah. And simultaneous existence of an architectural space across the world and across the globe is something that is possible with the kind of technology and the apparatus we have right now. So that there are so many new layers that get added here. And I think in a way, it is far more accessible, the architecture or the kind of spaces that we create, for a lot lesser financial input.
That's yeah. Potentially, yes. Potentially, yeah. Okay, I'm gonna throw a couple of things two things in a single pot here, and ask you as well as Kavita and Takbir about this primarily, although everybody else can answer. There was we're using the terms generative design and rapid prototyping or prototyping. And then there's the archaic term of modeling, right? They're all essentially the same thing in different ways. Joseph, when he in his talk, he was talking about the problem of the digital values taking over, and Kavita talked about a different way of thinking, right? Especially in India, right? Digital thinking, what's the percentage of people who can even remotely conceive of digital thinking in India? It might be 10%, it might, out of 1.3 billion people, right? So there's an issue there. Now, the other issue, which has not been mentioned here, but which is, I think, really a future issue, is algorithm design. Technicians are designing the way our banks work and things like that, right? So with this idea of like generative design and rapid prototyping, always keeping in mind this idea of a well-being, like ultimately the goal is that we have better cities and we have better spaces to live in and better things to do, right? So I'm kind of, if you want to be purely technological, maybe I'm pushing you a little bit, because you say, I don't care about all that. I'm just really enjoying this technology. I'm really enjoying making this work. But as researchers and as educators, there's still that thing. It's got to touch ground. It's got to touch the human. So I wanted to ask Vamsi, and then I guess Takbir, because she's been here a long time. So you gave her talk, and then Kavita, or yeah, if you can speak to this idea of like the way generative design can go in the future when we're talking about automation and the algorithm, and how those can relate to the qualities that architecture is supposed to provide, architecture / well-being.
Right. I think for the most part, what we understand, like you rightly mentioned, Professor Michael, the generative design currently is being used as a driver to produce architectural forms. And so that's probably why you're also seeing a similarity between modeling versus generative design or versus algorithmic design, or all these lingo that comes into place. So probably the end result, when you see it as a physical architectural form, you might put them in the same ground. But what essentially the generative design does is it gives you a certain level of control, a certain level of optimization that is different from conventional modeling. And I think you can include a lot of parameters, like the initial parameters and how you want the final result to be. There's a lot more room for variation, a lot more room for optimization, a lot more room for achieving the quality of well-being in the case of a generative approach. And I think it does not end simply with the form, because that's probably one dimension of it. It also expands into a space. I think we need to start assessing the data or the information about the quality of spaces, the usage of spaces, and there should be a lot more assessments that can also be taken into account. And you can use algorithmic or generative processes to come up with a much more better quality circulation, quality spatial arrangement in an architectural and urban space.
I completely agree with you, Vamsi, and I also would like to add that definitely, like you said, we can have a better optimization of space and a more robust design, but also when we think about material, you can have material optimization. And also we can start to think about a more circular, construction sort of process where we can have processes that allow us to have a kind of cradle to cradle process, that a recyclable kind of architecture or reusable kind of system that is recreating the same rather than, let's say, rather than just discarding buildings, which is how things used to be before, the bulky kind of buildings that we used to have. But now we're able to very precisely determine what the future life of the building would be like, and then how it could be reused and reconfigured to adapt to new uses. And that can be done only when there is data embedded into the building system. So actually, we're not designing one building, but we're designing infinite buildings or infinite products or infinite designs, which are embedded with data. And then you change the parameters and you're able to add on new parameters and be able to get many more results. So I think it's also from an environmental or climatic point of view, it's more optimized and a better sort of system. So you're designing a system rather than designing a single solution.
Yeah, I would like to, kind of, I think what they've said, I also want to, kind of put that into a synchronized form because I'm ending it. One thing is, firstly, answering the first question of that amount of Indians that, kind of use in digitalization, I would say, I would definitely agree with you with respect to construction industry. I would say we are only this much, but then when it comes to the other industries, particularly when I'm working with automobile and robotic industry, digitization is very, very important. The amount of technologies that they use, I would say every single person who works in that office should be specialized in something. And I would like to just point one thing here with respect to construction industry that happened a year ago. I don't want to mention the architects, but then the team of architects that were working on a really complex form were struggling when it came to manufacturing of that product because it had a little bit of complex form. So they needed someone who could model. So this is the modeling part that I'm jumping into, your second point. Model was very, very important for manufacturing. It had to be optimized for manufacturing, right? So if you design something, particularly when it is a little bit complex, it needs the intervention of the 3D model to be perfect to be manufactured. So that is another small example that I wanted to give because these days, most of the construction companies, contractors work with a lot of machines to optimize their solutions in terms of, saving money, cost efficiency, sustainability, and so on. So yeah, 3D modeling becomes a very important part. And when it comes to generative design, I think one of the most key aspects that have kind of helped us is customization, right? Apart from us making a multiple set of forms, how do you customize the same product for multiple set of users? So that is a very, very key thing about generative design. And yeah, definitely rapid prototyping is kind of help people refine their thoughts or to test it, basically user testing and kind of refine their thoughts and then come back to the generative design. So I would say all these three are completely different. Generative design, I would say it will be the first step. And then how do you model for generative design and how do you rapid prototype? So these three are process that, kind of, as Tagbir said and Vamsi said, it's a circular economy that you need to strive with one another. Yeah, so that's my thought on the question.
I also wanted to add that, in business, you have this term minimum viable product. So you're putting out the most easily, created product, be it virtual or a real prototyped design. And then you get to test it really quick and get the kind of user, feedback just the way app developers do. So you're actually able to test these things in reality through rapid prototyping, and then you're able to recreate and improve the product and put it back out there.
I just wanted to bring in a point here about how does in a generative design process, you try to achieve certain amount of optimization, but how does human perception play a role in this? And particularly, we're talking about artificial intelligence. So there was a time that people would give you a questionnaire to find out if this building is good or bad, whatever it is. But now the building itself is reading you. So it's telling you whether you like it or not. If you don't like it, it'll kick you out of the building, So this is really a strange thing. When AutoCAD was introduced in India, I tell you what, so all the library or the attached to it was all Western models. You understand what I mean? It took quite a bit of time for us to adapt into this situation. But now we have similar software, similar digital tools, which are completely not totally localized or contextualized, but it's completely based on Western models. And how does that in a country like India, would be, especially when, all these tools which are quite complicated, when what Michael was just telling that how much of India's population can take up this much amount of digitalization. He said 10%. I think that's completely too much of consideration. I think I would say just about 2%. So not 10%. So how do these things be like, for example, a fractal workshop, which we've been doing for the past 10 years, I suppose. I mean, it's a big fun for our students to learn, understand the spatiality of elements and all that stuff. But in reality, when you do a pavilion in Dubai or do a pavilion in like, for example, Takbir Fatima showed a kind of an installation in Hyderabad in high design. I don't really understand it, how does it suit the cultural aspect of the or contextualize the local cultural thoughts, and putting up a steel structure there right in the middle. It's just some kind of a sculptural system, but it might have quite a lot of digital thought process going into it. But how do people look at it? Do they feel that those things are part of it? I don't know. It's just a question. I'm a digital guy, but it just, these things come into my mind.
I think that's where the concept of the digital vernacular comes in, which I talked about, where we have, a kind of marriage between computational design and local material and local craftsmanship. And then in a workshop previously, which we had done using bamboo in VIT, in the VIT campus, where we had used bamboo, but we had used the kind of design methodology that goes towards generative design. So it involves the methods and processes of generative design, but you're using local material and you're involving the local labor to kind of be able to learn the craft from them, and then to recreate these designs. And that's the same thing that we did in Hyderabad and Dubai as well, using the local material that's available there. In Dubai, we learned from Bedouin women who are very well versed with this technology. And then in Hyderabad, we learned from the cane furniture manufacturers. So there is a kind of understanding between, we try to create a dialogue between the computational design as well as the local craft and the local material.
Yep, please.
Yes, Professor.
Go ahead.
Okay. Yeah, I think, I'd like to continue on what Takbir said. And I also understand Professor Jafar's question slightly differently. What Professor indicates is more from the empathetic point of view, I believe, because the kind of forms or kind of optimized solutions that come out of these machines are more often than not, they're not necessarily something that resonates with our anthropometric conditions or our present usage conditions. From what Takbir has done and talking about these kind of pavilions and installations, they act as these interesting short-term experiential spaces that you probably wouldn't inhabit for a long term. And that's also why it's experimental and it's more scaled down in nature. And probably when you want to scale up and make it into a residence or make it into a much more tangible, inhabitable space, there are a lot more challenges we still need to figure out. And this is where I personally believe that it is true that the digital adoption in countries like India is 10% or even less as 2%, like you rightly mentioned. But it is for the physical built environment. From the digital side of things, the way I understand it or the way I have noticed it is that we are capable of, like the people around us are capable of creating the next Tesla, the next self-driving car with really frugal innovation and really frugal strategies using the most cost-effective methods. So we also have that kind of digitization that's happening in parallel at the same time. it's only when it comes to the built environment that there is this challenge or there is this blockade that prevents us from going more advanced, more forward in terms of adoption of new technologies, because we are simply used to having the place the way we are habituated with. In an interesting way, I think all of us still have square rooms around us and we don't have anything beyond that currently.
Yeah, it's true.
But just to tell you that Elon Musk or SpaceX is here just because India has got a lot of money. And I can assure you in a year's time of production, Tesla will be the largest selling car in India.
Perhaps.
Yes.
You know, I was in terms of round rooms and that kind of thing. You might know Greg Lynn, who's teaching in Vienna. I've seen him quite often and spoken to him, and he said, you know, the whole blobitecture thing that he started with, which he calls it himself, blobitecture, he said it doesn't resonate, it doesn't work, you know. And he's moved on to sailboats and things like that. And of course, teaching, you know, he still works, but the whole ethos that he was developing, he said that there's no connection really, not only with the general world, but even within architecture, it starts to fade out once the novelty wears off. And you know, despite all of his experience, he says it's really, really tough to figure out how that can move forward. So, because there is no connection, say, to the other 98%, which, I mean, I would say in Canada, it's not much different. I know Canada well, I know Austria well. The percentage of people who are interested and knowledgeable is also quite low, right? But that, you're right, to me, it doesn't matter because ultimately it gets buried in the bamboo. It gets buried in the bricks. It can be buried in mud, so to speak. You know, you're working within that, and what you see is something tangible, which brings us back to that issue of the connection, you know, the connection. That's something that we, in a discussion like today, I was just struck by how we're all so interested in this zone that we're developing. And what fascinates me, and what I think would have to fascinate every architect in practice, is how it meets the expectations of the people and how they feel. So we're talking about POE, post-occupancy experience, evaluation, and PPOE, pre and post, where you actually create every building as an experiment by pre-loading it with the questions before you build it. That would be an approach too. And something that we don't teach in school. I mean, is that part of what you teach, Johnny? Is that something about the POE?
Yeah, that was part of my PhD. So yeah, it kind of fed into my PhD. I was involved with an architect when I was just going back 25 years ago, who did exactly that, Michael, who evolved their design, tested it, and took the benchmarks from the preceding design that worked and applied to the next design, and so on and so forth, looking at different materials and different builds as well. So I'm well versed to that. Hard to replicate in an educator's perspective. But from a research point of view, yeah, it has been done. But as you say, this was 25 years ago and nothing's much changed. It's not been widely adopted. All the promises made 20, 25 years ago when I first started in terms of sustainability haven't really come to fruition. But I think with generative design, and there's potential there. At the end of the day, all this kind of digital tools and digital design is really down to the scripting of it, and who scripts it and why they script it in a particular way. So the potential is still there to widely adopt it, I think, and that's the kind of angle I take from educative to educate the students, is to give them the platform to be able to test their ideas. As I said in my diagram of my presentation, it's a cyclical process. It has to be that process of going, testing an idea, gathering information, critical appraising it, drawing it, sketching it, drawing it. Then it doesn't work, try again, and that has to be more widely replicated in industry. Personally, it's too cash talks. Let's best be blunt about it. But the kind of cyclical process that generative design can help adopt could overcome that. I say could.
It would be great. You know, I know that Gensler has a really strong PPOE program or POE program. It would be great to have both of those presentations, kind of like what all this tech stuff go with the POE and all that. I think we've really drawn this out quite far. We're almost reaching 6 o'clock. I think, shall we close it, Deepika?
Yes, yeah, sure. All right. Thank
you
all
very much. Thank you very
yeah.
much for willingly answering my complicated assertions there.
Yeah. Thank you all for a fantastic discussion session. I thank all the panelists, the keynote speaker, and of course, Dr. Michael for making this session a fruitful one. It has been a wonderful 3 days with experts from diverse backgrounds, rich experiences, and from all over the world congregating at one point, sharing their perspectives, ideas, and also the work they do on architecture and technology. We have now come to the end of our 3-day program. I would like to invite architect Eddie Weir for some closing remarks.
Sorry, hopefully you can all hear me. So once again, good afternoon and good evening, everyone, depending on where you are. I'd like to sincerely thank you all on behalf of CIAT for attending this wonderful conference over the course of the last 3 days. I'd like to thank all of our speakers for all of their insight into the pretty amazing discipline of architectural technology. Thank you to Vellore Institute of Technology for collaborating with CIAT, and we look forward to working closely with you and other organizations, including the Council of Architecture and other universities, in promoting the discipline and profession of architectural technology, and of course the exciting opportunity of creating a hub in India to allow AT professionals and students to network and grow by creating an aspiration body of aspiring professionals. Special thanks to Professor Habib Khan, the President of the Council of Architecture, and Dr. G. Viswanathan, the Founder and Chancellor of VIAT. And we would also like to thank Dr. Jaffa Khan for being a wonderful advocate of architectural technology. And special thanks to Vidhu and Manichi and Deepika from VIAT for putting together this fantastic conference. Finally, I hope you and your families stay safe and well throughout this terrible coronavirus pandemic. Our thoughts and prayers and best wishes are with you all. What a wonderful conference and what an amazing time it is to be an AT. Take care and thanks again to everyone involved.
Thank you, sir. VSpark School of Architecture is certainly thankful for your support and wishes to continue our association with CIAT in the coming days. Thank you so much, Architect Eddie. I now invite our beloved director, Dr. Jafar A. Khan, to say a couple of words.
Thank you, Deepika. And first of all, I must tell you that we had this wonderful 3 days of exciting speakers right through, and so successful collaboration between the architecture school at VIT Vellore campus and the Chartered Institute of Architecture Technologists, and also the keynote speakers, Professor Habib Khan, the President of the Council of Architecture. On the inaugural function, he gave a wonderful talk and laid the complete base for the entire seminar. And also, it was a pleasure to have Eddie Weir, President of the Chartered Institute of Architecture Technologists. And I must give a special thank to Tara Page and Amina Khanam. And these are those wonderful ladies who have been behind all these things from CIAT. And we also had a wonderful young team from the architecture school, Vidhu, Meenakshi, Deepika, and many of the other team members, the faculty who are involved right through and relentlessly worked for the past few months to make this happen. And I must say that we have had some wonderful speakers from India, who have not only based in India, but also abroad. And we have great speakers from the UK, from Australia, and many other places. And this conference has gone on YouTube. The whole world has been watching us, and we've been getting quite a lot of appreciation from various fields of architecture technology. And we will be very happy to establish a CIAT base in India. And we are very happy to collaborate further in any of the programs the CIAT would be interested in. And thanks to our management, our chancellor who found time to be with us, and the entire team behind the top management to have cooperated and being with us to encourage us, and also the entire platform of Zoom offered by the CTS of VIT, which facilitated us the entire program. And wonderful speakers, wonderful keynotes. Thank you, Geeta. Thank you, Eddie. Thank you, Mark Oral. And thank you, Virgil Walsh. And all of you stay safe and be healthy, and take care of yourself. Thank you very much.
Thank you for your kind words, sir. It is only fulfilling to end this international webinar by sending our gratitude to all the experts who graciously accepted our invitation and presented themselves on this platform amidst such difficult times. I now request Professor Vidhu, convener of VIT CIAT International Webinar, to deliver a formal vote of thanks.
Thank you, Deepika. On behalf of VSpark family, it is with immense pleasure that I present this vote of thanks, which marks the culmination of this wonderful event. This is not an end, but instead a new beginning in which we embrace the technological aspects of field of architecture and try to amalgamate it in our daily lives. All the days saw an overwhelming registration by the participants, with day one having a mark of 388 people. The overwhelming participation was complemented by some fantastic talks by our keynote speakers and our brilliant panelists. First of all, I would like to thank our Chancellor, Dr. G. Vishwanathan, for being with us on day one and opening the webinar. I would like to thank Professor Habib Khan and Mr. Eddie Weir for being the chief guest and guest of honor respectively. They enlightened us on the significance of this seminar. I would also extend my thanks to the three keynote speakers, Mr. Fergal Walsh, Mr. Mark Orell, and Ms. Geeta Ramamurthy, who took us on a journey in their field of expertise and showed us how different agencies are carving their niche through digital technology in architecture. I would thank our brilliant panelists who are actively working in their respective fields to make this world a better place. They are the ones who form the crux of this webinar. Mr. Gordon Tissom, Mr. Gautam Tiwari, Architect Poonam Sardesai, Architect Sushant Verma, Dr. Boris Saranik, who graced the occasion on day one with their fantastic talks in the field of digital technology in architecture. Day two saw again an extremely brilliant conversation by Dr. Moole Chalal, Architect Varun Thotum, Dr. Amardeep Dugar, Mr. John Simpson, Dr. Karam Al-Abedi, and Ms. Sophia Key. They delved into the realms of built environmental ecology and how digital technology has marked its presence there. Last but not the least, day three, that is today, saw a zealous and inspiring deliberations by architect Takbir Fatima, Mr. Joe Healy, Dr. Bharat Aithal, Ms. Kavita Mohanraj, Mr. Vamsi Krishna, and Mr. Jonathan Scott. All of them helped us out to understand the impact of digital technology on the future of our cities, which is very important at this point of hour. I would also extend my thanks to the moderators, Architect Abid Rahim, Professor Sam Allwinkle, Architect Deepa Parekh, and Dr. Michael Tarasovich for steering this conversation into right direction. Last but not the least, I would extend my warm thanks to Dr. Jafar A. Khan to envisioning this conference into a success, and Ms. Tara and Ms. Amna for all their support from CIAT. I would thank Professor Meenakshi, who is the co-convener of this event, and Professor Deepika for a scintillating anchoring, which made this event into a success. I would also thank VIT CTS team, Mr. Thelapathy Selvam, and of course, our team of professors, especially Ms. Renuka and Ms. Zera, and others who have been tirelessly and continuously working behind the scenes to make this conference a success. Thanks to all. Have a very good day. And with this, we close this session of 3-day event.
Thank you all. Thank you all for being here. Have a great week ahead.
Thank you.
Thank you so much.
Thank you.
Thanks for this.
Thank you.
Bye.
Talk to you, Eddie, soon.
Bye.
I look forward to it.
Yeah.
Take care. Bye-bye.
Bye. Stay safe.
See you all. See you all.